I will request Shri Borasi ji to come over the dais. जोरदार तालियों से बोरासी साहब का भी अभिनंदन कीजिए। मैं श्री गोरखेड़े साहब से अनुरोध करूंगा कि आज के सत्र के चेयरमैन श्री निर्मल साहब का पुष्पगुच्छ भेंटकर अभिनंदन करें। श्री आर.डी. चौधरी साहब से अनुरोध है कि श्री बीपी बोरासी साहब का पुष्पगुच्छ भेंटकर अभिनंदन करें। आज का फर्स्ट लेक्चर डॉक्टर आई.के. पटेरिया साहब द्वारा दिया जाएगा। At present, he is Director Projects and Chief Quality Coordinator, NRIDA, New Delhi. The topic is PMGSY experience on implementation of new technologies. Second lecture will be given by Shri PMGSY, CGM, NHAI. The topic is automated machine guidelines and control technology. The third lecture will be given by Shri Alok Pandey. He is a structural engineer, Elegant Consulting Engineers. The topic is new equipment machinery technology for use in bridge project preparation and construction. The fourth and the last presentation will be given by Dr. Abhishek Mittal, CSIR, CRRI, New Delhi. And the topic will be new material and technology for construction and maintenance of flexible pavement. Now I will request Dr. I.K. Pataria, Shri PMGSY, Shri Alok Pandey, and Dr. Abhishek Mittal to come over the dais, please. Welcome, sir. Please take your seat, sir. जोरदार तालियों से अभिनंदन करिए हमारे चारों महानुभावों का. Please, sir. Now, I will hand over the mic to Chairman of the session, Shri Nirmal Saab. Thank you.
So, good afternoon, everybody. As you all know that this two-day seminar is mostly dedicated to emerging trends and new technologies. And tomorrow we will have a discussion on EPC contract execution. So when we are talking about the new technology, I think there is no doubt about the necessity of bringing new technology innovations in our works, day-to-day works. As I already told you that since the year 2000, for last 24 years, 25 years, we have taken up ambitious road development program, both for national highways in the form of NSDP initially, and now there are many other variants, and there are balance works, and now new expressway, access control expressways are being constructed in the coming years, as informed by previous secretary also, present chief secretary here. And at the same time, PMGSY also, they are doing a lot of work on rural road development, and recently their next phase has also been approved. So use program is there for rural roads also. But from where the material will come? Because it will all require the resources, and resources means aggregates, soil, cement, all kind of materials. So to see that this requirement is met for our future program, there is urgent necessity that we bring out new materials, new technologies, and see what the other countries are doing, how to do that in India, and what are our Indian indigenous R&Ds, how we utilize them, how we make the optimum use of the available resources. We use the aggregates which are generally not suitable, marginal aggregates, how to use them. So all these subjects will come now when we talk about the new ambitious road development program. And in fact, IRC has taken a lead role in bringing this new technology. First of all, unless there is a provision in the contract, you cannot use any technology, any new technology, because everybody will go by the contract document. So first of all, we introduced in the manual, because when you are doing highway work, then you need to have a manual. So 2-lane, 4-lane, 6-lane expressway manuals were drafted, and we made a provision in the manual itself that any new technology for which even though there is no IRC code available, that also will be allowed. So contractually, first of all, there should be a provision in the contract that yes, you will allow any new technology even if there is no code in India. So enabling provisions must be made, first of all. So that role we have done by bringing it all in the manual. And second role was that how to bring confidence in the users, because no PWD officer or no government officer will allow any new technology for which there is no guideline available. So how to bring confidence in those government officers which are implementing these technologies, these contracts. So for that purpose, we have set up a committee, as I was telling in the inaugural session also, that there is an accreditation committee in IRC which allows any patented material, any technology, any equipment which is not being produced in India, which is there internationally available. So that technology you can bring to this committee. And we have a committee of experts. There are 25 experts from different areas. I mean, from academics, from research institutions, from implementing agencies. And they are examining these new technology for which no code is available in India. And then they are approving it for initially for trial basis. And after that approval, the approval letter has got the sanctity that any PWD officer can allow this particular technology for trial use. And once we find that it is successfully used, then we can bring into code. So that once it is in code, then it is all in the public domain and mainstreaming is there. So these two things, first of all, to make the provision in the contract and then to allow these technology which are internationally best practices, but not being used. So this is how, I mean, we can bring this new method and technology. And secondly, that how to utilize this optimum use of these materials, even the waste material. So we have brought out the codes even for using all the waste materials. In different states, there are different kind of materials, so how these can be used. For these various guidelines have come in the recent years. In the last 4 or 5 years, we have done a lot of new documents, and these are the documents which you can refer. We have even our catalogs, you can see them. And still we are now bringing the new documents on these new technologies. So without wasting much time on this area, because we have 4 experts from different areas. And we had, in PMGSY, we had a very good experience of use of these innovative materials and technology in the rural roads. And Dr. Pateria has done a lot of work in that area. So I'm happy that he's here for sharing his PMGSY experience on implementation of new technologies. So I will now request Mr. Pateria to take the floor. And because of the rescheduling, certain time limitations we have given that 20 minutes each we are giving to each speaker. And then we will have 10 minutes of floor intervention. So I will now invite Dr. Pateria for his presentation. Thank you.
ये स्क्रीन उसके साथ मूव होगी। No, we are from there already. उसको चालू करिए कि ये दोनों स्क्रीन तो कनेक्टेड होना चाहिए. स्क्रीन नहीं चाहिए.
Respected Chairman Sir, Secretary General IRC, respected Vice Chairperson, my fellow presenters, senior officers from Public Works Department of Madhya Pradesh, and my fellow engineers sitting over here. सबसे पहले मैं इंडियन रोड्स कांग्रेस का आभार व्यक्त करना चाहूँगा, साथ में मध्य प्रदेश पब्लिक वर्क्स डिपार्टमेंट का भी, कि मुझे मेरे गृह राज्य मध्य प्रदेश की धरती पर प्रधानमंत्री ग्राम सड़क योजना के अपने एक्सपीरियंसेस को शेयर करने के लिए एज एन एक्सपर्ट यहाँ इनवाइट किया. थैंक यू सर, थैंक यू वेरी मच. It is my proud privilege to be here and share my experiences. Initially, I was asked to make this presentation for 40 minutes time. However, there is absolutely no issue. The presentation will be finished in 20 minutes time. I will be just running through a little fast and will try to cover it up in the revised schedule. I hope Madhya Pradesh is very much familiar with the Pradhan Mantri Gram Sadak Yojana, because the first road of Pradhan Mantri Gram Sadak Yojana was inaugurated in my native district, Shivpuri, 24 years back by the then Minister for Rural Development, Sri Venkaiah Naidu ji. Madhya Pradesh has done lot of work in collaboration with Government of India on Pradhan Mantri Gram Sadak Yojana, and I will be just showing the progress of the scheme along with what we have achieved under implementation of various new technologies. The slides are not changing, so how the screen will move, I do not know. In fact, in the morning session, honorable ministers also referred to Pradhan Mantri Gram Sadak Yojana and said that a huge length of roads has been already constructed. To be more precise, I would just like to add that till now, if you visit the website of PMGSY, as on today, probably you will find almost 7.73 lakh kilometers of roads have been either constructed or upgraded. I feel privileged also to inform this House that out of the 7.73 lakh kilometers, almost 1 lakh kilometer has been done in the state of Madhya Pradesh alone. Because I hail from Madhya Pradesh, I recall the situation of the roads in those days when I was a student, and even when I was working till the year 2002, 3, 4, the network was really in a very bad shape, in very poor condition, and today, now we have moved a lot, in which lot of new technologies have also been tried, and now, as Secretary General in the opening remarks said, that The new phase of PMGSY has also been announced, which has been approved by the cabinet just 2 months back. We are in the process of preparation of the detailed guidelines, which are likely to be released maybe in a week's time or so. So then this phase will also start implementation.
Hello, is there any problem in that connectivity or what?
Yes, sir, there is a problem. Some technical problem. They are getting the cable late हो रहे हैं.
Then how will we see it? यहाँ तो सब ठीक है. लेकिन वहाँ से रन करूँ.
हेलो, ऊपर भी बालकनी अभी पूरी खाली पड़ी है. अभी हमारे जितने भी सीनियर ऑफिसर या आए हैं बाहर के, वो ऊपर बालकनी में भी ऊपर जाके बैठ सकते हैं. वहाँ पर भी लगभग 100 के ऊपर सीट है ऊपर. वहाँ की एंट्री कहाँ से होगी कृपया बता दें सभी को, तो ऊपर भी जाके आराम से बैठ सकते हैं. बालकनी में जाने की एंट्री पीछे से है. पूनम उधर से चले जाओ, पीछे से, पीछे बालकनी में ऊपर चले जाओ. सभी को पीछे से ले जाओ बालकनी में.
उसको मूव करके देखिए. देखो स्क्रीन गया.
थोड़ी बड़ी केबल लाना, थोड़ी बड़ी.
डिस्प्ले कुछ और चला गया. डिस्प्ले कुछ और चला गया. ये तो चल गया.
इसमें कोई ऑडियो फाइल तो नहीं है?
नो.
ये रहा.
अविनाश वो उसको अमित को बुला लो, कहाँ पर है वो देख ले कुछ. Okay?
So now it is fine. So I'll start with how the PMGSY has started. Practically, as on date, these 4 verticals are being implemented. We started in the year 2000 with PMGSY, which later on has been renamed as PMGSY1 to differentiate it from other verticals. PMGSY has 2 components: new connectivity for unconnected habitations and upgradation of existing poor, which are not all-weather roads, to the standards of all-weather road. Was limited to 10 streets, and the last was limited to 10 streets, and the last vertical, which was started in 2019, again had a target of upgrading 1,25,000 kilometers of roads. The achievements are being displayed over here, and the sum of this leads to that 7.73 lakh kilometers, what I said in the beginning. These are year-on-year achievements. I'm just showing you just to have an idea regarding how PMGSY has achieved the construction of 7.7 lakh kilometers of roads. Now, with a basic introduction of PMGSY, what was discussed in the morning session during inaugural as to different new technologies are to be adopted. So what is the need of adoption of these new technologies? Honorable Minister focused on depleting natural resources and protection of environment. So these are the 2 focal points with reduction in the cost. So with all these issues taken together for promoting the use of locally available materials, for promoting the use of various technologies which have been developed through research and development in various institutions and which are already proven or the trials are yet to be taken. With these objectives, we started to make enabling framework for making use of the new technologies. We found that there are various issues in implementation of the new technologies and people are reluctant in adoption of these new technologies, practically because of these 7-8 reasons. So we tried to make enabling framework in 2013 in the form of guidelines by analyzing these various regions why the technologies are not being adopted. Knowledge, so we started training programs. Regarding design requirements, again through trainings, this has been addressed. Fear of failure of new technology, this has been addressed by making enabling provision, which Honorable Minister also referred to in the morning session, that in case a new technology project fails, then no penal action will be taken against anyone who has implemented it under PMGSY. Then how to carry out the rate analysis. Mostly the rates of different items of works are prepared by in the form of schedule of rates for which a format is prescribed by Indian Roads Congress. Because these are new technologies, no such framework is available. So we tried to provide such framework or such formats from NRIDA side to our implementing states to carry out the rate analysis so that our officers are not questioned at a later stage as to how you have put in so much of cement, how you have taken the quantities of these items in this manner. Fear of strict quality control, so by training programs, we try to boost the confidence among the officers that there is nothing likely to go wrong if you do it in the right way. We try to also provide information about life cycle cost, and reluctance was reduced over a period of time. Mainstreaming of existing new technologies, we divided it in 2 parts. Technologies for which IRC specifications are already available, but they are not being used on a large scale. They have been finding place even in the textbook, but the implementing officers have apprehensions and are not ready to make use of these. So these are listed in first column. There are many technologies which have been used on pilot basis, but for them the IRC specifications are not yet published. they have been listed on this side. As Secretary General said that IRC has a system of accreditation of new materials which are coming as commercial chemical materials in the market. So these technologies or materials have been accredited and they were also not finding place for implementation. So we made enabling provision for that also. So in the form of guidelines, when we published in 2013, an effort was made that let us make a bare minimum provision among the annual proposals that this much every state has to do. So we decided that 10% of the length of annual proposals being brought by any state will be by using new technologies with IRC specifications, and 5% of the length of the total proposal being brought will be with those technologies. New technologies are being used. No subcontracting is permitted for such projects, and making the stage passing to be mandatory for all such projects. In order to further handhold the implementing agencies, in many cases such do-it-yourself kind of guidelines or booklets have been published, because in some cases the IRC guidelines are there, but going through it, understanding it, and implementing it is little difficult. So just like videos, these do-it-yourself booklets have been published, and they are available on our website for free download. These are the colored booklets, so available for free download by anyone. Then after implementing for say around 10 years or so, in 2022, it was realized that people are adopting soft ways of implementing the technologies and are not implementing those technologies which will really lead to reduction in the cost, which will really lead to protection of environment in a big way. Mostly two technologies were adopted during the last 10 years on a very large scale. These are cold mix technology and waste plastic technology. And these have been implemented mostly in the surface course. So after realizing that this is not giving much benefits, only pilot projects are being used as CTB, CTSB, steel slag, and some other projects, but not on a very large scale. So during a conference, international conference, which was held in New Delhi in 2022, the guidelines were further revised and brought out in the form of Vision 2022, wherein the provisions have been made for implementing various technologies in different layers. That if you are going for surface course, then you have to make use of minimum length around 70% of your annual proposal by using waste plastic. Minimum 25% length of annual proposals by using cold mix technology. Mechanized surface dressing for different categories of traffic. Then for sub-base course and base course, specific provisions have been brought out. At least 50% of the length of proposals shall be constructed using new or green technologies, either in sub-base, base course, or subgrade. So stabilization has been made mandatory almost for 50% of the length in any one of the layers. 100% proposed length under cement concrete shall be constructed using thin white topping or shell-filled concrete. We stopped sanctioning the traditional cement concrete pavements. Either it will be shell-filled concrete or white topping, and there also, even going beyond the IRC guidelines, where 85% of the strength, designed strength, is acceptable, an advisory has been issued saying that pavement of cement concrete pavements will not be made unless the cores are tested and the strength is found to be 100% of the designed strength. So if it is M30 grade of concrete, we have to get M30, then only the pavements can be made. In case where pavement cost is high due to factors such as non-availability of aggregates leading to high transportation cost, FDR shall be preferred methodology. Most of you must have heard this technology has been adopted in a big way in the state of Uttar Pradesh. Because of non-availability of aggregates, they have adopted it on a very large scale, and the implementation is almost over. Only couple of few hundred kilometers are only balanced. In areas near thermal power plants, flyers shall be used in cement-treated base and embankments in adequate quantity, so as to make use of the available resources. In areas near steel plants, use of slag will be mandatory. Construction and demolition waste, wherever available, duly processed, shall be used in subbase and base course in at least 10% of the proposals. And jute and coil technology and similar such locally available materials shall be used for slope protection and even for improvement of the subgrade strength and as a filter material. I will be taking you through the various technologies, just showing a couple of photographs, and then at the end I will be showing the progress achieved by implementation of these various technologies. Cold mix, the most simple technology to apply, we can have either roadside mix or plant mix. Roadside mix has been permitted for very low volume works where the length is small, and plant mix by using the same hot mix plant with minor modification where heating is not required, and in place of heated bitumen, we are making use of the cold emulsions. So using a concrete mixer, the roadside mixing was permitted for low volume of work, and using the same hot mix plant by switching off the heating and making slight modification for using this cold mix. This is having the greatest advantage that you are not required to heat either bitumen or aggregates. Nothing is required to be heated. The laying is being done. Even the labor is not wearing boots. There is no heat. So easy to implement. Then coming to waste plastic, this technology has been adopted in the state of Madhya Pradesh on a very large scale. The implementation when we started was feeding the waste plastic through conveyor belt, but then it was reported and realized that feeding it through conveyor belt leads to burning of plastic to some extent. So shredders have been procured by various agencies. After collection of the roadside plastic, it is shredded as per IRC guidelines, and a small module, small addition to the hot mix plant was developed in the state of Punjab, and later on some plant manufacturers have also made this additional part in the hot mix plants itself, so that waste plastic can be fed into the plant itself. This is where we started feeding through the conveyor belt, training to various officials at different places. This is how the teams visited the different places and learned how the plastic is to be fed and how to avoid its burning from the fire. This is another view, because the plastic has to fall on the heated aggregate so that it will not burn. These are the roads constructed and finished one. Then coming to stabilization techniques. Now stabilization technique is a common word where we can make use of either lime, cement, flyers, a combination of these, or various commercial chemical stabilizers in combination with cement, or if the product manufacturer, product supplier says that my product works even without cement, then that can also be adopted. So we started making use of these CTB and CTSB by low-cost equipments, mixing through rotavator, tractor ribbon, and placing the bags in position and then opening it and spreading it through the grader. So these are some of the photographs: mixing through rotavator, checking, compaction of the base layer, curing, and these are the finished roads after 5 years of age. So There is absolutely no fear because this technology of cement stabilization is finding place in all IRC specifications and is in the books of highway engineering by Mr. Justo and Khanna for last 40, 45 years. Probably because of some issues in mixing and quality control, etc. These have not been adopted on a large scale, but in last 7, 8 years, now with the availability of IRC guidelines for design and its implementation, this is being adopted on a large scale. Another technology which has been adopted is paneled cement concrete technology, which is also being referred as white topping technology. Here we are finding only one issue, otherwise the technology is highly beneficial, reducing the cost, giving durable assets. The cutting of joints, because the design has been made with the understanding that the joints will be cut in 24 to 48 hours. And if the joints are not being cut within that period when the concrete is not completely set, the expected advantage is lost. And there is formation of hair cracks right at the surface. These can be viewed. And in large number of projects, it has been observed that the joints are not being cut at appropriate time, leading to development of cracks at a later stage. You can see Professor B.B. Pandey on ground helping us in implementation of this technology in the initial years. Roller compacted concrete pavement, IRC has already published the design guidelines, but this technology has also not been adopted on a large scale. These photographs are from Bhopal only. A road has been constructed very close to Bhopal in the year 2016-17, and I hope this road is absolutely in good condition as on date as well. This was, yes, I'll just take it. So, roller compacted, then same self-filled concrete pavement. This is also a technology developed by IIT Kharagpur. Professor Reddy is sitting over here, and we procured this technology. The rights for this technology, MORD has already procured, and we implemented it on a large scale in different states. Only one issue with this, that when we compact it, there may be deformation of these cells, which in some cases may be visible on the surface, but for rural roads, this is acceptable. We made use of jute and coir in the relevant areas where these are being produced. And for improvement of the subgrade, they have been used at the subgrade level. And for improvement in the existing bituminous pavements, while doing the resurfacing, a couple of projects have also been done by laying the jute sheets and then paving on this to avoid repeated formation of cracks and rutting. So same way, the coir geotextile, and later on the guidelines have been also published on jute and coir by Indian Roads Congress in 2020. Coming to the last technology which I am bringing over here, the full depth reclamation technology. Large number of projects have been executed, and this is the most suitable technology if implemented in a proper way. If implemented, that means the mixed design is crucial for the success of this technology. Selection of the road, and very critical is the basic engineering principles that the road level should not be below the adjoining ground level, because otherwise it will have all the issues related to drainage. So these are the only two references available as of now for implementation of this technology. One published by Indian Roads Congress for making use of commercial chemical stabilizers, and NRIDA has published a booklet in 2022 for full depth reclamation. The guidelines on this technology are under preparation. The group has already handed over to Indian Roads Congress, and we are expecting a final decision on publication of these guidelines. I'm just taking it through. These are the equipments being used in implementation of the full depth reclamation technology. This is applicable for, sir, need 2 minutes. Effective method of roadway rehabilitation and can be a cost-effective methodology for pavements in a number of scenarios. And these scenarios are given here. Cost of overlaying granular material is high. Aggregates are not available. Transportation costs are very high. Widening of the roadway to be done. Need to increase structural strength of roadway because of the increased volume of traffic. Asphalt pavement cross slope needs to be corrected, etc., etc. I already said that mixed design is to be done in a very systematic manner, and here we have really a challenge that the facility or the technical know-how for systematically designing the mixes for cement-treated bases, cement-treated sub-bases, and for full-depth reclamation technology are really not available in various parts of the country and are limited to the select institutions. These are the steps in construction process. This is the recycler in the first photograph. Second one is the detailed view of the recycling part of that equipment. And third one is the cement spreader. So this is a highly machine-focused technology. Cement is being spread through the cement spreader. The mixing is done through this recycler. Then the important part is the compaction. So various types of rollers are being used. Sheep foot roller, pad foot roller, so as to have maximum compaction. And then curing is to be done. We spelled acceptance criteria in tone with IRC guidelines, and whatever was left, we accommodated it in our booklet of NRIDA. These are the tests being carried out at ground. On the surface, it is mandatory to apply a crack relief layer. So 3 types of crack relief layers have been spelled out. One is geotextile layer, other one is chip seal or surface dressing, and third one, a full layer of 100 mm thickness of wet mix macadam. So out of these 3, any one can be used, and in most of the cases in the state of Uttar Pradesh, this geotextile layer has been used. So when geotextile layer is being used, we have to ensure that the compacted and cured surface is finished and the base layer is finished and do not have any loose material. A tech coat is to be applied over that. This layer is to be laid, ensuring that it is not extending beyond the carriageway, and it will be fully covered when we lay the bituminous surfacing. Otherwise, we can make use of 20 mm thick chip seal layer. This is how the surfacing is being done. Axis fabric, if being extended or if it is extending beyond the sides, that needs to be cut. Compaction of the bituminous concrete layer. This is a finished road. All these roads are very new. You can see a couple of roads which are which have been done. These are the advantages. These 2 limitations are very, very critical. We should not be under the impression that we are doing FDR, so this will resolve all the problems related to the construction of road or its performance. Absolutely not. So drainage problems needs to be addressed before we apply the full depth reclamation technology. Otherwise, we are likely to face many issues. These are, I'll just quickly run through. During various years, the road length sanctioned and under new technology, and the road length completed. This is showing since beginning. And I said that we issued these guidelines in 2013. So from beginning till 2012, the roads were sanctioned with traditional technology, but many of the roads could not be constructed. And later on, when these guidelines were implemented, these roads have been taken up with some or the other new technology, so they are appearing over here. Here at the bottom, you will see a total of 1,59,115 kilometers of roads have been sanctioned, out of which 1,10,000 kilometers have been already completed under this program. These are the state-wise data, and this is technology-wise data. All kind of technologies have been adopted. Thank you very much for patient hearing.
Thank you. I think you have seen that very rich experience is available already on our rural roads by using this. I know that we are not doing justice for reducing 40 minutes presentation to 20-25 minutes, but anyway, you can see, and there, I think all these things are available on your website also about the performance of states and various year-wise performance and all that. So thank you very much for this, and now I take you to a different world. From rural roads to we immediately go to the expressway kind of roads, and we see what NHAI is doing in the new technology. So the next topic is automated machine guidelines and control technology by Vivek Jaiswal.
थैंक यू वेरी मच। सबसे पहले तो मैं गवर्नमेंट ऑफ मध्य प्रदेश को बधाई देता हूं कि उन्होंने इतना बढ़िया इवेंट यहाँ ऑर्गेनाइज किया, एंड फिर आईआरसी को भी धन्यवाद है कि उन्होंने हमको मौका दिया कि हम जो कार्य कर रहे हैं उसको प्रदर्शित कर पाएँ आप सभी लोगों के सामने। क्या हो गया? बंद करो, उसको बंद करो। सो सर थैंक यू वेरी मच। अभी जो मैं आपके सामने ऑटोमेटेड मशीन गाइडेंस कंट्रोल टेक्नोलॉजी के बारे में जो आपसे शेयर करूंगा, ये सारी चीज़ें बेसिकली कुछ नहीं है, सिर्फ आज की डेट में जो टेक्नोलॉजीज अवेलेबल हैं उसको जो यूज़ किया है वो हमारी बहुत ही छोटी सी चीज़ों के लिए, जो कि हमको जैसे कॉम्पैक्शन करना है, जैसे कि टेम्परेचर मेंटेन करना है जब हमको ले करना है, या फिर जब हम रोलिंग कर रहे हैं। तो इस टेक्नोलॉजी को अडॉप्ट आज से करीब 1.5 साल पहले हमारे एक्स मेंबर थे आर.के. पांडे साहब, उन्होंने, और उनके साथ थे गिरी साहब, यहीं SATI विदिशा के पास आउट हैं वो भी। तो उन्होंने इसको, जैसा कि अभी निर्मल साहब ने अभी बताया था शुरू में कि कॉन्ट्रैक्ट में उसका प्रोविज़न करना है, तो उन्होंने इसका प्रोविज़न किया। लखनऊ कानपुर का जो पैकेज 2 है उसमें ये प्रोविज़न है, जिसके थ्रू मशीन गाइडेंस कंट्रोल सिस्टम की हमने अडॉप्ट करके वहाँ पे काम कर रहे हैं। अब और अभी फ़िलहाल इसको जो वहाँ पे देख रेख कर रहे हैं वो मिनिस्ट्री के ही बड़े काबिल ऑफिसर हैं सौरभ चौरसिया। जब हमने उनसे चर्चा करी तो उन्होंने खुद अपना जो वर्क कर रहे थे अपनी ही आवाज़ में डब करके उसको 3 वीडियो दिए हैं, जो कि मैं आप लोगों से शेयर करूँगा। इसमें बेसिकली मैं आपको जो कंटेंट्स हैं IRC के वो बता दूंगा, बेसिक प्रिंसिपल क्या है, फिर इंट्रोडक्शन ऑफ दिस 3 डायमेंशनल जो हमारी गाइडेड टेक्नोलॉजी है वो है, फिर रिजल्ट्स जो डिमॉन्स्ट्रेट कैसे कर सकते हैं वो है, फिर फाइनेंशियल इम्प्लीकेशन है, और फिर इम्प्लीमेंटेशन का प्रोसीजर। अगर आप देखें तो आज की डेट में टेक्नोलॉजी जो हमने आसपास देखी, एक तो जियो स्पेशल है, उसके साथ इंस्ट्रूमेंटेशन है और आर्टिफिशियल इंटेलिजेंस। इन 3 चीज़ों को यूज़ किया हमने ड्यूरिंग द कंस्ट्रक्शन और ड्यूरिंग द ऑपरेशन। अगर हम ड्यूरिंग द कंस्ट्रक्शन देखते हैं तो क्वालिटी और सर्टेनिटी दो चीज़ हमको जो पकड़नी है प्रोजेक्ट में। हमारे प्रोजेक्ट्स डिले होते हैं और हमारी जो सड़कें कभी कभी गड्ढा बन जाता है या फिर पॉटहोल बन जाते हैं, उनको एड्रेस करने के लिए कॉम्पैक्शन ही एक चीज़ है जिसको कि हमने इस मशीन गाइडेड सिस्टम से पकड़ा है। इसके बाद सर्टेनिटी की जब हम बात करते हैं तो इसमें फिर मैक्रो और माइक्रो लेवल की जो शेड्यूलिंग है वो करते हैं, जिसको कि अभी सेक्रेटरी साहब ने मॉर्निंग सेशन में बताया था कि डिजिटल ट्विन। तो डिजिटल ट्विन मीन्स जो कंस्ट्रक्शन हमको साइट पे करना है, जो रोड हमको 35 किलोमीटर की सड़क साइट पे बनानी है, उसको फिजिकल मॉडल ना बना के कंप्यूटराइज मॉडल बनाना, ये भी हम कोशिश कर रहे हैं। इसके साथ ऑपरेशन एंड मेंटेनेंस में जाते हैं तो जैसा कि हमारे मिनिस्टर ऑनरेबल मिनिस्टर साहब ने PWD गवर्नमेंट ऑफ मध्य प्रदेश, उन्होंने बताया था कि एक ऐप उन्होंने लगाई है। इसी तरीके से NHI ने भी ड्रोन एनालिटिक्स पावर्ड AI आर्टिफिशियल इंटेलिजेंस को यूज़ करके तत्पर ऐप बनाया है। इसके साथ ट्रैफिक सेफ्टी में भी ATMS के थ्रू और इंसिडेंट मैनेजमेंट के थ्रू इन्हीं सब टेक्नोलॉजी का यूज़ किया है। मैं आपसे इन सब टेक्नोलॉजी के बारे में नहीं, सिर्फ कॉम्पैक्शन को ही आज हम आपके सामने शेयर करेंगे। बेसिकली इस पूरी टेक्नोलॉजी को अगर आप देखेंगे तो जो हमारा 3D सिविल से जो डिज़ाइन बन के आता है, जो डिज़ाइन है हमारे पास, वो डिज़ाइन को 3D मॉडल में कन्वर्ट करते हैं। 3D मॉडल में कन्वर्ट करने के बाद सीधा का सीधा उसको हम गाइड कर देते हैं सॉफ्टवेयर के थ्रू मशीन्स के रोलर पे, ग्रेडर के ब्लेड पे, जिससे कि ये सारी चीज़ें जो हमको अडॉप्ट करना है, मैं आगे आपको दिखाऊंगा, ये सारी चीज़ ऑटोमेटेड गाइडेड हो जाती हैं और फिर हमको उसके रिजल्ट्स मिलते हैं, चाहे वो अर्थवर्क हो, चाहे कॉम्पैक्शन हो, चाहे ग्रेडिंग हो। अच्छा, इन सब चीज़ों में पकड़ने के लिए अगर आप देखेंगे तो IRC SP 97 2013 पूरा का पूरा IRC कोड है जो कि कॉम्पैक्शन इक्विपमेंट पे है। इसके साथ अगर आप देखेंगे तो MORTH की गाइडलाइन ये कहती है 305 में कि हमको 250 से ऊपर की लेयर में रोलिंग नहीं करनी है। अब ये सारी चीज़ें सब हमको पता है, सारी चीज़ें दिख रही हैं, लेकिन अपने आप साइट पे टेक्नोलॉजी को यूज़ करते हुए कैसे हो, वो सारी चीज़ यहाँ पे इस टेक्नोलॉजी में हमने एड्रेस करने की कोशिश करी है। इसी तरीके से अगर आप देखेंगे तो 902 मिनिस्ट्री का जो हमारा स्पेसिफिकेशन है, उसके 902 में टॉलरेंसेस बताए हुए हैं कि लेवल जो हमारा सरफेस है उसका क्या उसमें क्या टॉलरेंसेस हैं। जैसे कि ग्रेनुलर लेयर है तो ±15 mm, अगर बिटुमिनस लेयर है तो ±6 mm। तो ये सारी जो चीज़ें, इसके बाद रोलिंग का और लेइंग का जो टेम्परेचर है वो भी स्पेसिफाइड है यहाँ पर। इसी तरीके से कॉम्पैक्शन की जो वैल्यूज़ हैं वो भी स्पेसिफाइड हैं। तो ये सारी चीज़ें जो हमारे कोड में हैं वो अपने आप, क्योंकि सभी लोग कह रहे थे कि अथॉरिटी इंजीनियर के साथ थोड़ी सी परेशानी होती है, लेकिन अथॉरिटी इंजीनियर भी क्या करे, तो धीरे धीरे अब जब हमारे पास AI आ गया है तो हम क्यों ना उस चीज़ को उसका यूटिलाइज करें और उसको लेके आगे बढ़ें। तो इस पूरी टेक्नोलॉजी में अगर आप देखेंगे तो पहले डिज़ाइन है, फिर 3D मॉडल बनना है, उसके बाद वो ग्रेडिंग और कॉम्पैक्शन पे अपने आप चला जाता है। हाईवे को जब आप देखते हैं तो बेसिकली बहुत ईजी चीज़ है हाईवे, सिवाय लेयर के कॉम्पैक्शन के कुछ भी नहीं है। अगर आप देखेंगे तो मटेरियल ग्रेनुलर मटेरियल और बिटुमिनस मटेरियल है। फंक्शन क्या है बेसिकली हमारे, लेयरिंग करना, थिकनेस प्रोवाइड करना, मॉइस्चर कंटेंट को मेंटेन करना। इक्विपमेंट्स जो हम यूज़ कर रहे हैं बेसिकली वो ग्रेडर, सॉइल कॉम्पैक्टर, पेवर, कॉम्पैक्टर, ये सारी चीज़ें हम यूज़ कर रहे हैं। उनके जो फंक्शंस हैं, ग्रेडर का फंक्शन लेवलिंग और अचीविंग लेवल है, पेवर हमको लेयरिंग में लेवल्स देता है, कॉम्पैक्टर रोलिंग और कॉम्पैक्शन करता है। ये सारी चीज़ें हमको जानकारी है, मैं जस्ट रिवाइव कर रहा हूँ आप लोगों को। अब इसमें जो कंट्रोलिंग फैक्टर्स हैं अगर आप देखेंगे, जो कि हमने, जब मैंने आपसे कहा कि टेक्नोलॉजी में हमको जियो स्पेशल यूज़ करना है, तो जियो स्पेशल के लिए बेसिकली उसकी पोजीशनिंग, जो हमारा रोलर है, जो हमारा कॉम्पैक्टर है, जो हमारा ग्रेडर है, उसकी पोजीशनिंग हॉरिजॉन्टल और वर्टिकल पोजीशनिंग, जो कि हम ग्लोबल नेविगेशन सैटेलाइट सिस्टम, आपने टोलिंग के बारे में सुना होगा कि GNSS अडॉप्ट कर रहे हैं, यहाँ पे भी हम GNSS को ही यूज़ कर रहे हैं। फिर कॉम्पैक्शन के लिए लैब के पैरामीटर्स हैं, लेवल हम अपने एलिवेशन कोऑर्डिनेट जो हमारा ZG है उससे देख सकते हैं, टेम्परेचर को डिग्री में देखते ही हैं। तो बेसिक प्रिंसिपल हमारा ये है, जैसे ये हमारा क्रॉस सेक्शन है किसी भी रोड का, इस क्रॉस सेक्शन में अगर आप देखेंगे तो हम लेवल और पोजीशनिंग को कंट्रोल कर रहे हैं। किससे कंट्रोल कर रहे हैं? सेंसर, सॉफ्टवेयर और GNSS से। किसके लिए? एम्बैंकमेंट के लिए, सबग्रेड के लिए, जीएसबी, सीटीएसबी, डब्ल्यूएमएम, सीटीबी, डीबीएमबीसी। मेरे ख्याल से ये जितने भी शॉर्ट फॉर्म है सभी लोगों से आप सभी लोग परिचित हैं इससे। ये है हमारा बेड, जहाँ पे हमको एम्बैंकमेंट बनाना है। इस एम्बैंकमेंट के लिए हमको इसकी वर्टिकलिटी, मतलब किस लेवल पे रोलर चल रहा है, हम वो वर्टिकलिटी को, जो उसका वर्टिकल लेवल है उसको कंट्रोल कर रहे हैं, उसको एड्रेस कर रहे हैं। हम उसके हॉरिजॉन्टल मूवमेंट को कंट्रोल कर रहे हैं, हम उसके साथ उसके कॉम्पैक्शन को कंट्रोल कर रहे हैं। ये इस टेक्नोलॉजी में हम देख रहे हैं। बेसिकली क्या है इसमें, ये जितने भी हमारे इक्विपमेंट्स हैं सब सैटेलाइट से कनेक्टेड हैं। हमको परेशान होने की ज़रूरत नहीं है। ये सैटेलाइट सीधे हमको बता रहे हैं कि हम किस तरीके से काम करेंगे। तो 3 डायमेंशनल ऑटोमेटेड मशीन गाइडेंस सिस्टम, जनरली ये जो सॉफ्टवेयर है, दिस लिंक्स द डिज़ाइन सॉफ्टवेयर विद द, जो हमने डिज़ाइन किया है 3D सिविल में, जो हमने डिज़ाइन किया है वो सारे के सारे कोऑर्डिनेट्स सीधे मशीन के इक्विपमेंट पे आ जाते हैं और अकॉर्डिंगली वो डायरेक्ट करता है कंस्ट्रक्शन मशीनरी को उस लेवल के लिए। फिर जो इट ऑल्सो इंटीग्रेट द कंप्यूटर विद इन द कंस्ट्रक्शन इक्विपमेंट में जो हमारा इक्विपमेंट है, दैट इज जीएनएसएस के थ्रू वो अपनी पोजिशनिंग भेजता है। मैं आपको बताऊंगा कहाँ लगे होते हैं ये इंस्ट्रूमेंट्स। फिर इट इवेल्युएट्स द मशीन्स एक्चुअल हॉरिजॉन्टल एंड वर्टिकल पोजीशन, जो मैंने आपको पहले अभी बताया, और 3D जनरेटेड मॉडल जो हमने डिजाइन से किया हुआ है उससे कंपेयर करता है और अकॉर्डिंगली हमको रिजल्ट्स बताता है। फिर इसी सब चीज़ों को जो ऑपरेटर है वो वहाँ पे मशीन्स को गाइड करता है। अब ये है हमारा ग्रेडर। अगर आप देखेंगे तो ये ब्लेड के ऊपर अगर आप देखिए, ये 2 चीज़, ये है जीएनएसएस रिसीवर। कहीं हमको सर्वेयर की ज़रूरत नहीं है, कहीं हमको पैगिंग की ज़रूरत नहीं है, सीधा का सीधा ये जो रिसीवर है, ये इंफॉर्मेशन जो डिज़ाइन में आई है आपके पास, वो सीधे यहाँ पे ट्रांसफ़र हो रहा है ग्रेडर को। और ये जो ग्रेडर है, ये ग्रेडर के ब्लेड को सेट कर रहा है और कोशिश ये करता है कि जो हमारी लेयर है, ग्रेनुलर लेयर है, वो विद इन द टॉलरेंस लिमिट रहे, या फिर अगर नहीं भी रहे तो हमको एक डेटा दे देता है कलर के रूप में, जो मैं आपको आगे बताता हूँ। अब आप देखिए इस सारे सिस्टम में, जो कि ये राइट हैंड साइड वाला जो हमारा पिक है, ये बेसिकली लखनऊ कानपुर वाले सेक्शन का है, जिसमें कि 4 लेन बन रहा है, बीच में मीडियन है। लेफ्ट हैंड साइड पे देखिए ये सारी पैगिंग होती है, पैगिंग करने के बाद सर्वे होता है, और जब तक सर्वेयर नहीं साइड पे पहुंचता है तब तक रोलर और कॉम्पैक्टर अपना काम पे आगे नहीं बढ़ पाते। तो यहाँ पे स्ट्रेट अवे सीधे, चाहे रात हो, चाहे दिन हो, चाहे सवेरे 6 बजे हो, चाहे रात में 8 बजे हो, ये कॉम्पैक्टर्स, ये ग्रेडर, ये रोलर अपना काम सीधे कर सकते हैं। उनको डिपेंडेंसी खत्म हो गई है, इससे हमारी एफिशिएंसी भी बढ़ती है। अगर आप देखें तो मैंने आपको पीछे दिखाया कि ये ग्रेडिंग हो रही है। यहाँ पे आपके पास जो डेटा है वो कलर, ये सॉफ्टवेयर जो है वो कलर कोडिंग के रूप में आ जाता है। 300 mm की लेयर पे रोलर चल रहा है, ग्रेडर चल रहा है, और एक एंड पे 700 मीटर के बाद वो नीचे जाता है। जब वो नीचे जाता है तो आप ये देखिए उसके कलर का जो डिफरेंस है वो दिखाई पड़ता है। इस तरीके से आपको ये सारी चीज़ें मिलती हैं यहाँ पर। फिर हम किस लेवल पे हैं, हमने क्या लेवल अचीव कर लिया है, यहाँ से इस सॉफ्टवेयर से ये सारी चीज़ें भी हमको मिलती है। वो तो पिछले, अगर आप इसको देखेंगे तो ये करीब 25 से 30 मीटर की बात है, लेकिन जब आप 10 किलोमीटर 28 से किलोमीटर 38 की देखेंगे तो कहाँ पे लेवल कितना अचीव हो गया है, सबग्रेड लेवल पे क्या है, सीटीएसबी लेवल पे क्या है, ये सारी इंफॉर्मेशन आपको ये जो ऑटोमेटेड मशीन गाइडेंस का जो सॉफ्टवेयर है ये आपको दे देगा। और उसने सारी जो जियो स्पेशल की इंफॉर्मेशन है उसको यूटिलाइज करते हुए। अगर आप देखें कॉम्पैक्टर, तो कॉम्पैक्टर के ये इक्विपमेंट्स हैं जो जिसमें अगेन जीएनएसएस रिसीवर लगे हुए हैं। इसमें आप देखिए जनरली जब आप पहुंचते हैं साइट पे तो पासेस के काउंट पे निर्भर करते हैं। पासेस के काउंट कहाँ पे कितने मार दिए हैं, वो जो ड्राइवर ने अगर पासेस के काउंट करेक्ट मारे हैं, उसको 7 पासेस मारने हैं, उसने मार दिए हैं तो कोई बात ही नहीं है, हम ये मानते हैं कि कॉम्पैक्शन अचीव हो गया होगा। तो यहाँ से हम ये देख सकते हैं कि पासेस उस पर्टिकुलर स्ट्रेच में कितने हो गए हैं। ये रिकॉर्ड जो ईपीसी कॉन्ट्रैक्टर है, उस कॉन्ट्रैक्टर ने क्या किया है, ये सारा रिकॉर्ड जनरेट होके वहाँ पे रह जाएगा। उसके बाद जो एक्शन लेना हो अधिकारी वो एक्शन ले सकता है। हमारी डिपेंडेंसी अथॉरिटी इंजीनियर पे एकदम ख़त्म हो गई है जब हम इसकी बात करते हैं इस टेक्नोलॉजी की। अगर आप देखिए तो यहाँ पे लेफ्ट हैंड साइड में 1 2 3 4 5 6 7 8 9 पासेस मैंने आपको बताए हुए हैं। इन 9 पासेस के डिफरेंट कलर कोड्स हैं। जहाँ जहाँ पे जितने भी पासेस आपको चाहिए, ये कलर कोडिंग आपको बता देगा कि आपने कितने पासेस मार लिए हैं। अगर पूरा ग्रीन दिख रहा है, यस इट्स ओके, आपका ये स्ट्रेच ओके है। इसी तरीके से अगर आप देखेंगे तो नंबर ऑफ पासेस को आप कलर कोडिंग में डिस्प्ले कर सकते हैं। और अगर कहीं पे आपका लेस कॉम्पैक्शन है तो वो आपको दिखा देगा। फिर कहीं पे अगर लिफ्ट आपकी 300 mm से ज़्यादा पे उसने करी है, उसका लेवल 300 mm से ज़्यादा है, तो वो भी रिकॉर्ड हो जाएगा। इस तरीके से हम डिफरेंट लेयर के जो पास काउंट की जो मैपिंग है इस पर कर सकते हैं। इसके साथ उसमें जो कॉम्पैक्टर मीटर वैल्यू है, जो उसमें सेंसर लगा हुआ है, इस समय हमारा IS कोड या MORTH बेसिकली एक 200 कहता है कि 1000 क्यूबिक मीटर के एम्बैंकमेंट पे आपको एक टेस्ट करना है फील्ड डेंसिटी। यहाँ पे आपका चप्पा चप्पा सारी चीज़ें आपके पास कॉम्पैक्शन इसमें दिख रहा है। तो कलर कोडिंग से आपको पता चल रहा है ब्लू स्पॉट जितने भी हैं वो सारे के सारे आपकी अगर वैल्यू डिफाइंड वैल्यू CMV की 12 है तो 12 से कम है, कहीं पे ज़्यादा हो गया है तो वो दिख रहा है। तो ये सारे रिजल्ट्स आपके पास पहुंच रहे हैं, आप डिसाइड कर सकते हैं। ये है टेक्नोलॉजी का यूज़। इसी तरीके से पेवर पे जब आप पहुंचते हैं तो पेवर पे हम फिर रोबोटिक टोटल स्टेशन के साथ पेवर पे भी इंस्ट्रूमेंट लगाते हैं और थर्मामीटर भी लगाते हैं। यहाँ पे बेसिकली अगर आप देखेंगे तो ये जो टोटल रोबोटिक्स टोटल स्टेशन है, ये इंफॉर्मेशन भेजता है पेवर को, और हमको स्ट्रिंग लगाने की ज़रूरत नहीं है। सीधे का सीधे ये GNSS से ही सारे डेटा ले रहा है और उसके बाद ले कर रहा है। चाहे वो लेवल हो, चाहे वो कॉम्पैक्शन हो, चाहे वो टेम्परेचर हो, तीनों ही चीज़ आपको यहाँ इस टेक्नोलॉजी से मिल रही है। इसमें भी अगर आप देखेंगे तो लेवल अगर इस जगह पे यहाँ पे अगर आप देखेंगे तो लेवल अचीव नहीं हुआ है। प्लस माइनस जो टॉलरेंस लिमिट है हमारी ±6 mm बिटुमिनस के लिए, वो हमको नहीं मिली है। तो ऐसे पॉइंट्स भी ये आपको बता देगा। इसके बाद जो डिसीजन लेना है, अगर ऐसे स्पॉट्स सपोज कीजिए कि 20% से ज़्यादा हैं तो हम उसको रिजेक्ट कर सकते हैं, ये कह सकते हैं कि हाँ दोबारा करो। इसी के साथ अगर आप देखेंगे तो हमारे पास मशीन के नाम के साथ उसका टेम्परेचर है। पहले पास पे अगर आप देखेंगे तो 130 डिग्री था, उसके बाद 132, 120, 118, 105, 104, जैसे जैसे पासेस बढ़े हैं वैसे वैसे टेम्परेचर कम होता गया है और पासेस होते गए हैं। तो ये सारी इन्फॉर्मेशन हमारे पास यहाँ से आ रही है। इवन हम टेम्परेचर को भी देख सकते हैं। यहाँ पे देखिए छोटे छोटे से ब्लू पैचेस जो आपको दिख रहे हैं, ये सब वो पैचेस हैं जहाँ पे टेम्परेचर 70 डिग्री से कम था। ये सारी इन्फॉर्मेशन रिकॉर्ड हो रही है अपने आप ही आपके इस जियोस्पेशल AI और इंस्ट्रूमेंटेशन से। ये सारी चीज़ें हुई। अच्छा, जब हम इसको अब देखते हैं, जब हमने इसको मैपिंग करी कि हमारे पूरा का पूरा जो 16.5 मीटर का एम्बैंकमेंट था, हमको ऊपर करीब 10 मीटर की सड़क चाहिए चौड़ी, नीचे जो 16 मीटर का एम्बैंकमेंट था, उसमें जब हमने उसको देखा तो जो टॉलरेंस लिमिट थी सरफेस की, वो WMM की जो हमारी सरफेस की लेयर थी, देखिए रेड पैचेस कितने सारे हैं लेफ्ट हैंड साइड में कन्वेंशनल मेथड में। लेकिन जब इस मशीन के साथ गए, कॉन्ट्रैक्टर को भी पता था कि ये सारी चीज़ें रिकॉर्ड हो रही हैं। PNC वहाँ पे कॉन्ट्रैक्टर है, PNC ने इसको अडॉप्ट किया। PNC को भी थैंक यू कि कम से कम उसने इस टेक्नोलॉजी को यूज़ कर रहा है वो। तो हमारी ये रेड पैचेस बहुत कम हो गए हैं। इसी तरीके से अगर आप देखोगे DBM लेयर पे, तो जो +-6 mm का टॉलरेंस लिमिट है, वो लेफ्ट हैंड साइड के मैपिंग में रेड कलर आपको ज़्यादा दिख रहा है बनस्पत राइट हैंड साइड की तरफ। तो इस तरीके से टेक्नोलॉजी को यूज़ करते हुए हम आगे के काम कर सकते हैं। अब बात यह है कि ये प्रोजेक्ट इस समय लखनऊ कानपुर पे PNC का जो पैकेज है, पैकेज 2 उन्नाव के पास, वहाँ पे चल रहा है। इसको मैं तो ये कहूँगा कि गवर्नमेंट ऑफ मध्य प्रदेश, मेरे ख्याल से ENC साहब से रिक्वेस्ट करूँगा, थैंक यू वेरी मच कि उन्होंने ये पूरा सेशन करवाया। एक टीम को ज़रूर वहाँ भेजें, उसको बिल देखने। बहुत शानदार चीज़ है, बहुत ही एक्साइटिंग चीज़ है ये। अब इसमें आज की डेट में हमारे पास जो प्लेयर्स हैं मार्केट में, जो जितना जानकारी मुझे है, वो एक तो है टॉपकॉन पोजीशन सिस्टम, दूसरा है आपका ट्रिम्बल नेविगेशन, तीसरा है लाइका जियो सिस्टम। फिलहाल जैसा कि गडकरी साहब कह रहे थे, ऑनरेबल मिनिस्टर साहब, कि शुरू में जब कोई टेक्नोलॉजी आती है तो महंगी दिखाई पड़ती है, बट टू बी वेरी फ्रैंक, अभी जब मैं आपको कॉस्ट बताऊंगा तो आपको कॉस्ट बहुत ज़्यादा नहीं लगनी चाहिए, मुझे तो नहीं लगती है, लेकिन फिर भी ये कॉस्टिंग और नीचे आएगी। इस पूरी टेक्नोलॉजी की जो कॉस्टिंग है, बेसिकली अगर आप देखें तो ग्रेडर पे करीब 70 लाख का ये सिस्टम है, कॉम्पैक्टर पे 35 लाख का सिस्टम है, पेवर के ऊपर 1.5 करोड़ का सिस्टम है ये, क्योंकि उसमें 4 ऑटोमेटेड रोबोटिक टोटल स्टेशन लगते हैं, जो कि जब आपका पेवर चलता है तो कहीं रुकना नहीं चाहिए, आपको वो जो लाइन आ जाती है मतलब जब हमको जर्क देता है, वो सारी चीज़ों को रोकने के लिए लगातार हमको टोटल स्टेशन चेंज करते रहने पड़ते हैं रोबोटिक, तो उसकी वजह से यहाँ पे ये कॉस्टिंग है। अच्छा, अगर आप देखें 45 किलोमीटर 45 के आसपास की जो हमारा एक पैकेज है, उस पैकेज की कॉस्टिंग जनरली 800 के करीब आती है। उस पर जब हम देखते हैं तो हमारी ये कॉस्टिंग 7 करोड़ बैठती है। 7 करोड़ टू बी वेरी फ्रैंक एक प्रोजेक्ट पे 0.75% है। ये 0.75% मिनिमम से मिनिमम 6 प्रोजेक्ट पे चलेगा ये सारी टेक्नोलॉजी, तो हमको करीब ये मान के चलिए कि 0.1 या 0.15% ही पड़ेगा, कोई बहुत महंगी टेक्नोलॉजी नहीं है ये। और हम सब जितने भी हमारे यहाँ पे जो हमारी फर्टर्निटी के लोग हैं, उन सबको जितना आराम मिल जाएगा, जितना सुकून मिल जाएगा, वो सारी चीज़ें हम यहाँ अडॉप्ट कर सकते हैं, मिल सकती है हमको ये। सर बस मैं अब रही बात, जैसा निर्मल साहब कह रहे थे कि इसको इम्प्लीमेंट कैसे करेंगे, तो NHAI ने इसको लखनऊ कानपुर वाले पैकेज पे किया था, अब आगे के प्रोजेक्ट्स पे भी NHAI करने वाली है। ड्यूरिंग द हमने इसको मॉनिटर भी किया, मॉनिटर करने के बाद जो चैलेंजेस हमने देखे, अवेलेबिलिटी ऑफ द नेटवर्क, ठीक है, उसको भी हम सुधारेंगे। फिर एक्यूरेसी ऑफ द एस्टेब्लिश TBMs हैं, वो भी एक चैलेंज है। फिर एनालिसिस ऑफ द रिपोर्ट्स, ट्रेंड ऑपरेटर्स, लेस एजेंसीज टू असिस्ट दिस इसकी इम्प्लीमेंटेशन करने के लिए। अब इसको हम इम्प्लीमेंट कैसे करेंगे, जो पांडे साहब ने किया था और जो साहब ने भी हमसे अभी शुरू में कहा कि हाउ वी विल इम्प्लीमेंट इट। तो सबसे पहली चीज़ शेड्यूल डी, हमारा EPC डॉक्यूमेंट जो है उसका एक 3 पेज का हमने बना रखा है, वो भी मैं आप लोगों से शेयर कर लूँगा। उसमें बेसिकली डेफिनेशन है, डेफिनेशन के बाद ऑब्लिगेशन ऑफ कॉन्ट्रैक्टर्स हैं, उसके बाद क्या उसकी डिटेल स्पेसिफिकेशन है, जो CMS है सेंट्रलाइज मॉनिटरिंग सॉफ्टवेयर है वो क्या है, जितने ग्रेडर और उस पर जो मशीन्स लगनी है उसकी क्या सिस्टम है, वो हमने इस पर मेंशन किए हुए हैं। ये रेडिली अवेलेबल है। अभी NHAI में EC में इसको कंसीडर होना है, कंसीडर होने के बाद ये बाकी के सभी प्रोजेक्ट्स पे इसको इम्प्लीमेंट कर लिया जाएगा। तो बेसिकली मैं आपसे यही शेयर करना चाहता था। इसके साथ मैं आपको बस एक वीडियो शेयर करना चाहूँगा। एक मिनट सुनना, वो लगाना वीडियो। ये वीडियो देखने के बाद नहीं IRC पहले आप ग्रेडर का चलाओ।
In the AMG technology, the highway engineer have to set up the GNSS base station at the nearest known TBM, whereas in the conventional method, highway surveyor have to start with total station to mark horizontal alignment, and accordingly another team member transfers the edge side point by using the measuring tape, and then second team member marks white chalk powder on all points, and at these markings a stake rods will be placed. Reduced levels are marked on the stakes with the help of auto levels. The grader operator start doing grading with breaking the heaps. Operator breaks the heaps and do the profiling on pure guesswork, whereas the AMG technology essentially bypasses the traditional process of grading by using stakes. Instead of giving site plans to the surveyor, who uses these plans to manually set the stakes, and then having the machine operator, visually guided by a site engineer, read those stakes. A 3D control system puts the site plan on a screen directly in front of the machine operator. An onboard computer in the machine's cab has a digital copy of the site plans stored in its memory, and a machine receiver combined with various onboard sensors. The grader operator breaks the heaps, and profiling is done as per the guidance received from the display mounted on the cabin. The operator can see the real-time cut and fill data of profile, and he can spread the material accordingly. After profiling, in conventional method, operator is purely dependent upon the guidance received from the site engineer. and while laying the material, he has to stop each time so that the site engineer can check the levels using measuring scales, whereas with AMG technology, system determine how far the cutting edge is from grade level and sends a signal to the hydraulics to drive the blade to grade level. The productivity achieved by using the technology is 336 cubic meter per hour, whereas with conventional method, productivity can be achieved only up to 113 cubic meter per hour. Another advantage is that we can work day and night with technology fitted grader. However, in conventional method, operations can be done during the daylight only.
ये जो छोटी सी क्लिपिंग है, ये बेसिकली लखनऊ कानपुर स्ट्रेच की है। ये आवाज़ भी वहाँ के पीडी सौरभ चौरसिया की है। उन्होंने खुद इस चीज़ को किया है और आप लोग जब इसको अडॉप्ट करेंगे तो चलो।
Compaction technology. Once the grading process is done, compactor starts compacting the road using AMG technology. In AMG technology, a GNS receiver is mounted on the top of the cabin of compactor, which helps collecting position data of compactor drum. With onboard screen mounted on the cabin, operator gets the guidance about the number of passes, and once target passes achieved, is screen indicated by green color on that area. The authority can monitor the compaction process remotely. In conventional way, there is no option available to monitor the process remotely, and also there is no way in which compactor operator gets the guidance. Advanced compaction technology.
ये लास्ट है जिसको कि हमने पेवर पे छोटी सी क्लिपिंग बनाई थी, पेवर वाली लो।
Comparison of conventional paving versus automated machine guidance technology. In the AMG technology method, the surveyor has to start with setup of a robotic total station using known control point. After this, the surveyor connects the robotic total station with a 360-degree prism, which are mounted on the top of the paver screed. The onboard system will calculate the position at the bottom of screed edge. Whereas in the conventional method, first the survey team will provide the center line and mark the points on the proposed bed, followed by fixing of peg rods on the markings. After this, by using auto level, the civil team member fixes the reduced level as per the FRL sheet of the proposed crust. The trucks start loading the material to the paver, and both the pavers start to spread the WMM material. In the AMG technology method, on-board monitor is mounted on the paver in which the surface design of the proposed crust is loaded. The 360-degree prism calculate the current position of screed and through design machine calculate the level adjustment automatically. To ensure better quality with the help of a grade check system and controller, the engineer can check the grade levels easily during laying. In the conventional method, paver is following string wire using the contact sensor. By using a thread and a measuring scale, a worker checks the level of the layer. If there are any changes in the level, the worker adjusts it using the side panels.
ये कॉन्ट्रैक्टर फ्रेंडली भी है, कॉन्ट्रैक्टर खुद भी इसको अडॉप्ट करना चाहेगा तो
कंपैरिजन ऑफ कन्वेंशनल,
तो मैं रिक्वेस्ट करूंगा कि एनसी साहब से कि इस टेक्नोलॉजी को जरूर विटनेस कराएं। थैंक यू वेरी मच सर, थैंक यू सर।
Thank you. This is how we have seen that how we can use the new technology in compaction and bringing the automated technology and automatic inbuilt quality. This will bring inbuilt quality in the system. So the next presentation, now we have seen the compaction and we have seen the experience of rural roads, and now we are talking about the bridge projects, how we can bring the new technology in bridges, project preparation and construction. Sri Alok Pandey, who is a structural engineer, Elegant Consulting Engineers. So, Pandey sir, please.
Thank you very much, sir, for giving me this opportunity.
whatever little bit knowledge I've got related to bridges, just going to share that. So without wasting time, because we have already got very less time. I've divided this into 4 parts basically. First of all, we will be talking about innovative materials. And then we will be talking about enhancing features of any bridge, how to enhance features of a bridge basically. Unfortunately, many places I'm seeing aesthetics is missing in our country. So that's what I have included that also, what is the latest architecture of the bridges across the globe. And fortunately, I also got some opportunity to design some unique aesthetics in our country. So that also I'm going to share with you. And then modern construction technologies or techniques. This is what I have divided into 4 parts. So let us talk about innovative materials. There are many basically, but these are the materials I have selected here. In the morning, Minister Sir was also talking about ultra-high performance concrete, so I have started with that only. Then I'll be talking about architectural concrete also. Concrete is not only concrete basically, we can create anything, which we will see also. And then self-compacting concrete, because many places we have got reinforcement, congestion and all those things. We have got narrow spaces and all those. So their self-compacting concrete is very, very useful. You don't require any compaction. It is going to behave like water or liquid basically. So automatically going to compact every space basically. So about that also we are going to talk. Then sustainable concrete. Let me tell you, this is what is world's first priority nowadays basically. We are talking about design life of a bridge which is 100 years basically. We are going for so many developments and all those things. But let us think, for example, if we are going to kill our earth in next 25 years or something like that, then why to go for 100 years development? So the first priority nowadays is to preserve the nature basically. If we are going to kill the earth in next 25 years or 30 years, then why to go for these many developments basically? So we will be talking about that also. Weathering steel is a structural steel where you don't require any painting or any maintenance or something like that basically. So we will be talking about that. Many other possibilities are also there, innovative materials are there. But let us talk only about these because we have got very limited time. If you see this table basically, this is what concrete can be divided into many categories. As you can see, I'll be sharing this copy of the presentation, not reading everything basically. Ultra high performance concrete. It is not only ultra high strength, it has got many other features also. And when we talk about the strength of this concrete, in the laboratory, they have achieved up to M250 grade, which is as good as steel. So this is what has already been achieved in the laboratory. Bridges are being constructed using M180 or up to M200 grade concrete basically. It is, as I said, it is not only having ultra high strength, it has got many other features also. For example, if you see the permeability, it is 1,000 times less permeable than normal concrete. So this is what basically, so it has got much better durability also, it has got, much better workability also. So many other features are also there in this concrete. So just moving further because we have got very limited time. So what to do basically to achieve ultra high performance concrete, we require mineral admixtures as compared to chemical admixtures. And then maybe we can achieve we can enhance many properties of the concrete. If anybody is interested, then this is what is a report published by US Department of Transportation. So it is available on the net, you can simply get. And one very interesting book is also published by John Willey. So this also I hope you can get online, so you can see this book also. So all those properties and all those things are there. Let us just see a few examples here. So this is first bridge is in France. It is constructed in France. As you can see, because of ultra high performance concrete, they could reduce the weight of superstructure by 34%. Actually, as compared to 100%, it is only 34% weight. Steel was reduced from 39 ton to 32 ton only, and pre-stressing steel from 17.4 ton to 6 metric ton basically. So this is what, and as Minister Sir also said in the beginning basically, any technology has got some initial cost, but finally we are going to have saving basically. Finally we are going to get durable concrete. It is, we are going to get sustainable concrete and all those things because concrete consumption is less. So we are, that way we are, saving the natural resources also. In the second bridge, which is constructed in South Korea, basically grade of concrete used was M180 and deck weight could be reduced by 50%. So this is what is the achievement basically. So many possibilities are there, many features are there. It is economical because of, reduction in the weight, you start getting reduced seismic forces. So further economy, it is a sustainable development. You can start using your structure at earlier stages also. And it has got very high tensile strength also. Let me tell you, we consider while designing concrete structure, tensile strength of concrete as 0. Generally, we don't consider any tensile strength of concrete while designing anything. But here, if we talk about flexural tension, M50 is the tensile strength of this concrete. You can imagine the tensile strength also it has got basically. Now let us come to architectural concrete. Architectural concrete means you can create anything. For example, all these are pure concrete, no patchwork, no repair, no painting. This is what is possible with concrete. As you can see, the bridge also at the top, constructed in US basically. So this is what they are doing basically. That is how they are adding aesthetics to a structure basically. Self-compacting concrete, as I said, it is behaving like a liquid, so much better compaction. You can, you don't have to worry about congestion of steel or something like that. So you can see the slump result and all those things. And these are the bridges basically which have been constructed using self-compacting concrete. If you have got any complex shape of the structure basically, then this is what is the solution basically, rather than getting voids, getting honeycombing and all those things. So this is what is the solution. I'm going to share this presentation, so not reading everything. Definitely it is going to result into reduced cost of the formwork, faster construction because you don't have to compact the concrete, early strength gain, much better durability, no honeycombing and all those things basically. Now let us come to sustainable concrete. As I said, preserving nature is the first priority. We have to preserve the earth. So there are many possibilities. We have to use something so that we can preserve the nature. For example, if at least in non-structural member, maybe we can use some existing concrete of any existing structure which has already lived its life. So if we can take concrete from there and maybe we can use that in parapet or maybe non-structural member. So there are many ways basically. For example, definition here is it is environmental friendly concrete which helps in preserving the nature basically. So how to get sustainable concrete, all those possibilities are written here. I'm not going to read that basically. You can simply go through it. I'll be sharing this. Weathering steel. You don't have to paint this steel for a period of about 120 years. It is so durable steel basically. You don't require any maintenance or something like that. Internationally, this is what is in common practice. Unfortunately, not in our country. And other thing is, with time, it changes color also. So it is changing its aesthetics part also. So for example, this bridge is constructed in, I think it is in US, weathering steel. In that, those areas, US and Canada, they are very commonly using it. They are generally going for weathering steel only. So all those features are positive and negative parts. No negative part, basically only positives are there. So written here, you can simply go through it. And then enhancing features of a bridge, basically. So integral bridges are very, very, you can say, innovative design. Just to explain you, for example, if I'm standing like this, you apply a force on me, horizontal force on me, I'm not so stable. But if I spread my leg like this, I'm stable enough. So this is what is the difference between integral bridge and normal bridge, basically. Integral bridges have got much better performance, specifically in earthquake condition or wherever horizontal forces are there. They are maintenance-free bridge because integral bridge means we are integrating substructure and superstructure like building. We don't have any bearings or something like that. So there also we are avoiding bearings. We are able to avoid expansion joints also. So it is durable structure. It is maintenance-free structure. It has got much better riding quality. So many features are there. Even RC6 is also recommending. The limitation or negative part of integral bridges, it is subjected to additional forces because of temperature changes. So we have to take care of that basically. So, and then we will be talking about long lifespan bridges. Now people have started thinking about increasing lifespan of a bridge. I'll be sharing one bridge in Australia basically, where maybe I think 15-20% more money they put, but they have achieved a design life of 300 years. So in long term, it is much economical also. It is sustainable also. So all those things we will be seeing. Hybrid bridges, it is a combination of steel and concrete. We will see that also. Butterfly web girder bridges, generally used in Japan. So we will be seeing those photographs also. and base isolations. Base isolations means creating flexibility to our structure. So time period increases, it starts attracting lesser seismic forces. So in earthquake, we start getting economy. So this is what? So integral bridges, these are the integral bridges constructed worldwide. So here in this specific bridge, integral length is about 560 meter length. 560 meter, no bearing, all the piers are monolithically connected to the deck slab. Now you can imagine the situation. This is another example where integral length is 650 meter, moving slightly fast because of time constant. This bridge is also, you can say, integral, no bearings, no intermediate expansion joints. Fortunately, this I designed, it is located on NH only in Himachal, Chakki bridge. So total length of the bridge is about 520 meter, no bearing, but definitely some intermediate expansion joints were provided to avoid, additional forces, large forces because of temperature changes. By providing twin pier like this, basically, expansion joints were added. So this is another flyover which I could design in Assam. Total length, I think, is about 200 meter or something like that. So central 4 piers were integrated, and then bearings were provided over the end piers to avoid large forces because of temperature changes. Definitely when we talk about integral structures, we have to go for thorough analysis, and all those things are there basically. This is another integral bridge, you can say, constructed in Assam only. Concrete quality is good, definitely. Finishing is not so good, but concrete quality is actually good here. And all the piers, B-type piers are there. They have got another added advantages basically. So no bearings, no expansion joints. So this is another example in the country. And all those positive parts I have written here. Limitation is definitely additional forces because of temperature changes, which has to be taken care. I was talking about long lifespan bridges. So this is the bridge constructed in Australia. They could achieve a design life of 300 years just by spending maybe 15 or 20% more money. But finally, if you see the saving, 3 times more design life just by putting 10 or 15 or 20% more money. So this is how they could do. Everything is written here, moving slightly fast because of time. Hybrid bridges I was talking about. So if we talk about, for example, normal box girders which we are using like this, so webs are generally 300 millimeter thick or something like that. So what they have done is specifically in Japan, these inclined webs, if you see, these inclined webs, it is actually this much thickness is not needed. So they have replaced these inclined webs with corrugated steel plates. So they could reduce the weight of the bridge. So this is what you can see. Webs are provided in corrugated steel plate. Top slab is in concrete, bottom slab is in concrete. So weight reduction up to 25% is possible. And I think about 10 to 15% finally saving also possible. There may not be possible in our country because it will be a new technology in our country. But there they are saving about 10 to 15% money. Butterfly web girder bridges also. Webs, again they have replaced, rather than thick web, they have gone for very thin web. As I said, generally web thickness is 300 millimeter or something like that. So they went for about web thickness of 150 millimeter, 50% reduction in the web thickness, and then they have added openings also, you can see. So these webs are pre-stressed concrete. So here also weight reduction and maybe 10-15% economy also, because it is in regular usage there. Base isolation, as I said, generally we use rubber lead bearing basically between the foundation or substructure or substructure and superstructure. So this way we add flexibility to the structure. So if my structure is more flexible, it is going to attract lesser seismic forces. So going to give lots of economy. So this also very relatively old technology, but not common in our country. Let us talk about architecture of bridges, which I was talking about, unfortunately generally ignored in our country. For example, look at this bridge. It is not only aesthetics, it is much more economical also. The thing is they are using the concepts of structures basically, utilizing structural behavior and all those things basically. Look at this one, for example, altogether different aesthetics they are talking about. It is constructed in Japan. For example, this is a concrete arch bridge, I think 416 meter long concrete arch bridge. This is again 445 meter long concrete arch bridge. Here, this arch and I think inclined piers are in steel, deck slab is in concrete. And now you can see, now they are going for single ribs also. which is very interesting and very unique shape basically. So this bridge also about 1.2 kilometer long bridge. That is how they are talking about aesthetics basically, doing something different. And let me just tell you, aesthetics mean nowadays going for unsymmetrical structure. Symmetry is, we are forgetting about symmetry. We are now, whether it is building, whether it is bridges, we have started going for unsymmetrical structure. So for example, look at this one. This is known as infinity bridge because of bridge along with its reflection forms a symbol of infinity. So infinity bridge won many awards. For example, look at this bridge. Below the bridge, there is a navigational span basically. So when ship passes below this, and because they don't have enough clearance, so they can rotate or they can tilt the entire bridge like that, you can see. And you can see the size of jacks and all those things which they are using basically. So single arch bridges like this basically, this is known as network arch bridge, very unique aesthetics it has got. Now even trusses also unsymmetrical, this is what. Look at this one, this is also unsymmetrical structure or maybe unique shape. Now these are the bridges I could get opportunity to design on national highways, specifically in Himachal. So this is again unsymmetrical bridge, completely integral, no bearings, no expansion joint, very well recognized internationally, total length is 115 meters. So you can see the shape moving slightly fast. When we talk about these bridges, definitely while designing, we have to take pains. So we have to go for 3D modeling or maybe finite element or something like that. And then detailing also very important, because in this specific bridge, reinforcement were passing in many directions, maybe 5 directions. So we have to make sure that there is sufficient space for the concrete to flow. So that is how you can see the detailing, and you can see the reinforcement also. You can comfortably realize that even in 5 directions, there is no reinforcement condition. This is what was ensured. This bridge also deliberately done in unsymmetrical. Again, in Himachal, fortunately, I got opportunity. Half arch supported on inclined pier. It was not required by the department, but still we tried to do something different. So this is again 95-meter long bridge, no bearings, no expansion joint, unsymmetrical. This also has been recognized internationally. And this also, it is again on the national highway in Himachal again. Unsymmetry was created deliberately here also. 55 meter, 50 meter is the length. So again, arches and all those things, these are in Himachal. Here also, central arch is complete and then half arch on either side, on either ends basically, done deliberately just to create something different. So this also, modern construction technique, this is what actually they are doing, specifically when you talk about in US. They specifically call it accelerated bridge construction technique, ABC technique. In this technique, A to Z is precast. Precasting A to Z is ABC technique. For example, if it is open foundation, it is precast. If it is abutment wall, it is precast. If it is pier, it is precast. Maybe here you can see pier along with foundation is precast. They are going even for pile also, it is precast pile. There are many advantages of precast pile. You can see those hollow piles. These are hollow precast piles. They are much cheaper also as compared to traditional piles which we are using basically, and most commonly used piles across the globe. So even pile cap also precast, piers also, pier cap also, superstructure, everything is precast. Then only they call it ABC technique. So this is what all ABC technique, even arches also precast. Small structures like culvert and all those also precast. This bridge also, this is I think world first precast network arch bridge. It was again completely precast, about I think 600 meter length or something like that, and rather than 12 months it could be constructed only in 5 months time. This is what is the benefit. Let me tell you, biggest advantage of precast construction is time saving, and then much better quality control is the second advantage. Definitely it may not be economical when it is beginning, otherwise may be economical also. So here, for example, left bridge, total 53 precast pieces were used in the left bridge, and right one, for example, if you see, the bridge could be constructed only in 8 days time. This is what is the advantage of precast construction. So all those positive parts are written here, and then transportation of precast members. So definitely, maybe we can use overhead gantries, and now we have got in our country gantries which are wheel mounted also. For example, this is the gantry which is used in bullet train project basically, where big members are there basically. So it can be rail mounted gantry, it can be wheel mounted gantry like this, for example. For a small or medium size precast girders or member, these are the low bedded trailer which can be used. And if it is a big member basically, then maybe we may require a special truck with multiple axle and a steerable trailer in the rear also if needed. So that is how we can transport it. And then launching of girders in precast construction. So for example, this is what is the new technology you might be seeing also. So it can be overhead launching girder like this to erect precast construction. It is also overhead launching girder. For example, this also overhead launching girder. Many types are there basically. So you can see such a big span they are launching here. And then overhead again, then maybe we can use underslung launching girder. And launching girder means you don't require anything from the ground level, basically. If you have got facility, we can use that. Otherwise, if ground is not accessible, then this is what is very, very helpful, using launching girder. And then very briefly, let us talk about precast segmental methodology in arches also. This is also very well recognized bridge internationally constructed in US, basically. You can see even arches also in small precast pieces. Just finishing, sir, maybe in 1 minute. So then maybe this bridge, fortunately, I got opportunity to design. Here also it is constructed on form traveler. 930-meter length is the bridge. Not even a single expansion joint is provided in the deck slab. And you would not believe that this was beginning of my career. So this is what is possible, let me tell you. Everything is possible. This bridge I designed about 25 years ago in Malaysia. 930-meter, no expansion joint. This is what? So everything is possible, and internationally, actually, big experts, they are literally playing with this structure, let me tell you. This also bridge I designed in the beginning of my career in Himachal on National Highway, 120-meter span, I think longest concrete arch bridge of the country. Here also, in both the cases, construction was done from the top. Nothing was taken from the ground because of a continuous flow of water. So here also, same methodology of construction was used. In Himachal, near Kullu, this bridge is located. Balanced cantilever method also useful where ground facilities are not there. So this is also many bridges have been constructed in our country also using balanced cantilever. And last one, incremental launching of bridge superstructure. This also, if you can't do anything from ground level, then this is what is the methodology. Entire bridge superstructure is cast behind one of the abutment and then it is pushed towards the river side or valley side. And for that you require a launching nose or something like that. You can see there. Even this bridge which we saw earlier, this was also incremental launching. You can see the launching nose which is attached there. And then this is Bogeybill bridge in Assam, which is very well recognized bridge, basically quite a long bridge. So this also international incremental launching here also was used. Finally, thank you so much. I think 1 or 2 minutes more I have taken, but try to finish. Thank you so much, everybody.
Thank you, Mr. Alok Pandey, for bringing various options available for bridge design, bridge construction. We have seen all the technologies used in this. And now we come to the last presentation on flexible pavement. So new materials and technology in flexible pavement by Dr. Abhishek Mittal from CRI.
A very good afternoon to all of you. First of all, I would like to thank the organizers and the PWD government of Madhya Pradesh for organizing this seminar and giving me this opportunity. Because of the shortage of time, I'll quickly skip some of the slides because the presentation has been made keeping in timeline of 40 minutes. But we know that we have the second largest road network in the world and majority of the roads in our country are basically flexible pavements. For a flexible pavement, it's a multi-layer structure, so you require aggregates and bitumen, and most of the aggregates that we get is from the quarrying source. And for the bitumen, we require or we do the fractional distillation. So, and these two sources or these two materials are scarce, so we need to think of alternative materials and new technologies, how we can preserve these materials and use less of them. Currently, the three challenges which the asphalt paving industry is facing, that it is the material consumption or material availability that is depleting very fast, because road construction industry, they are big guzzlers of materials, so you require a lot of material for construction, and obviously a lot of fuel is required for transporting these materials. As per the report of material consumption patterns in India, by 2027 we will require more than 10 billion tons of material, and the material rise is exponentially going, and the way we are constructing highways almost 50 kilometers a day on a national level, obviously we expect that this trend is going to increase in future also. And obviously these resources are very limited, which will last for the next 20, 25 years. So we need to think of alternate sources or technologies where we consume less of these materials without compromising on the quality of the pavements that we construct. Second is obviously because of the environmental pollution, one has to look for alternative techniques and more environmental friendly paving mixtures that we can think of, because the construction industry is one of the biggest emitters of carbon dioxide, and as per the vision of our Honorable Prime Minister, we have to be net zero by 2070. So we need to develop technologies, green technology, which will be less environmentally polluting and will be green technologies. And we are facing many premature pavement failures. Roads are failing every year. So this is again a big concern. This could be because of the heavy overloading and because of the climatic patterns that are actually changing. The current binders or the materials that we are using, they are not able to cope with the current loading conditions. And also we know that because of the climate change, the entire earth is heating up. This is a heat map of the country wherein you can see that except some parts of the northern India and some part in the southern part of the country, almost the entire country has temperatures more than close to 45 or 46 degrees. These are air temperatures, and when we talk about pavement temperatures, they would be somewhat almost 15 to 20 degrees higher than this. And you might have read in news some days back, like in the month of May or June, that somewhere temperatures more than 50 degrees have also been recorded. So temperature is really heating up. So are these binders really able to cope with these high temperatures? That is a big concern that is there. Obviously, such kind of pavements are not desirable. So we need to think of some alternative technologies, and Albert Einstein has said that the world we have created today has problems which cannot be solved by thinking the way we thought when we created them. So ultimately, we need to think of out-of-the-box thinking one should have, and we need to have technologies which are not only new and innovative but also sustainable, because sustainability is a concept which includes the environment, which includes the social concept, and which also includes the economics. So we have a need to move towards sustainable asphalt pavements. Sustainability encompasses all three parameters of environment, social and economic concepts. And if we look at the Sustainable Development Goals which have been proposed by the United Nations, total 17 SDGs are there. And if typically we look at the goal number 9, which talks about the resilient infrastructure, inclusive sustainable industrialization, and foster innovation. And there are 8 targets for this SDG goal number 9. If you look at the goal target number 9.1, it talks about the developing quality, reliable, sustainable, and resilient infrastructure, including regional and trans-border infrastructure, to support economic development and human well-being with a focus on affordable and equitable access for all. So that means it encompasses all the 3 parameters of typical sustainability, which talks about the environment, which talks about economics, and which talks about the human well-being or the social element. So we need to have the sustainable asphalt pavements, which encompasses all these parameters, and the technologies that we develop or the technology which we adopt for the construction of pavements, they have to be sustainable in nature. But at the same time, why there is a need for innovation? I mean, we want to construct pavements which are sustainable, but is there a need to innovation? Because once a project is finalized, there are not many choices available with a particular agency, with engineer. You cannot change the project location at a later stage. You cannot change the design or alignment once it is finalized. You cannot even remove the materials, or if it is a soil, you cannot remove the entire earth or entire soil. That is really uneconomical. So the only option that is available is to have innovative material, and you can innovate with the alternate design. And it is not only that I'm talking about, and me and you are talking about the sustainable pavements, sustainability practices. Even the government of India has from time to time issued many circulars about the sustainable paving practices. It's a circular from December 2020, which is on the use of new and alternative technologies in the road construction process. Then they have also issued a circular on the value engineering practices, which basically talks about the sustainable highway development. And it also encompasses all the 3 parameters of sustainability, which is environment, social, and economics. There have been, the agencies have also been bringing about the compendium of new technologies. This is a BRO document. Then PMGSY has been taking the lead in implementing and the sustainable and new technologies in the road construction process. It's not only other agencies, IRC has also taken a lead and published number of documents on sustainable technologies. So this is a list of some documents which I could get. I don't claim it to be exhaustive list. There might be many more documents, but there is a good number of documents that has been published by IRC on sustainable technologies. So I'll be talking about some of the technologies for which the IRC codes are available, but they have not been implemented on a large scale. So I'll be talking about some some technologies like stabilization, warm mix asphalt, recycling of pavement, waste plastic, CGBM, high performance mixes, perpetual pavements, and the use of industrial waste. So we'll take each of them one by one. Stabilization, we know that it can be done either through mechanical or chemical stabilization. Chemical stabilization, we use either the conventional stabilizers or the commercial stabilizers that are available. So they basically, use of stabilization would result in either the change in gradation, increase the workability, strength and durability, and also leads to reduction in the plasticity. And there are a number of commercial stabilizers which are available. Some names I have quoted here, but there are many more stabilizers which have really come up in the field of chemical stabilization. The concept is very simple. You use a low quality material, which is basically a granular material, and add certain amount of either the commercial stabilizer or the chemical stabilizer, and you get a material which is strong enough. The result would be that your overall construction thickness or overall pavement thickness would reduce. That is the entire concept. So materials, we can use any material, including the aggregates as well as the marginal aggregates. We can use the rep material, and that is what we are doing in the FDR technology. If you do it in situ, it becomes a FDR technology. The concept is same, but since you are doing it in situ with using a recycler, as Dr. Pateria showed, that once you use a recycler, you use the in situ material, and you do the in situ stabilization, that becomes a FDR technology. We can use the industrial waste, construction demolition waste, all type of materials, but the only limitation is PI should be less than 10 if you are going for base stabilization, and PI should be less than 20 if you are going for sub-base stabilization. Other requirements for chemical stabilizers, obviously one has to check for the leachability characteristics so that they don't leach out heavy toxic metals into the groundwater. So one has to carry out the leachability test, that is through the TCLP test, and they have to meet the requirements of durability, flexure, and strength requirements. And once you do a stabilized layer, you have to provide a crack relief layer, which can be in the form of aggregate interlayer, in the form of a semi, that has to be provided. So these are the three options. For a stabilized pavement, you can either stabilize a base layer and sub-base layer both, or you can stabilize any of the layers. You can stabilize base and do not stabilize sub-base, or you can stabilize sub-base and do not stabilize base. So these are the three options that we have. So this is typically when you provide a granular crack relief layer in the form of a wet mix macadam. That is typically a 100 mm WMM layer that is being placed over a stabilized layer. The same we do in the case of a, when we go for a FDR, as Dr. Pateria also showed, that when you go for an FDR, you can also provide a crack relief layer. Second would be in the form of a SAMI. Instead of providing a crack relief layer of 100 mm thick, one can use a typical geosynthetic or geotextile membrane, or in the form of a SAMI. We can have a stabilized base and granular sub-base. This is other option that we can go. If you do not want to stabilize both base and sub-bases, also we can stabilize only the base layer, sub-base layer, and we can go with a granular base layer. So different options are available. You can go with stabilization of any of the layers or even both of the layers. Also for low volume roads, there are charts which given, wherein you can select like what type of stabilization is to be adopted, and depending on the traffic level and the subgrade soil category. Here we do not actually do the design of the pavement, but we take the thickness of the pavement from the chart itself. Obviously for any stabilized pavement, the mix design is very important. One has to do it carefully and actually select the optimum dosage of stabilizer after rigorous laboratory testing, and it has to be implemented very carefully in the field also. Design considerations like minimum UCS value of at least 4.5 has to be attained, and this is the value which has to be attained on the field. Typically when we do a mix design, the values that we get in the laboratory, that should be at least 10% higher of this. So minimum UCS that we design during the mix design process has to be 4.95 megapascal. For this, one has to do the mix design process. But there are certain questions which are still unanswered. There are many commercial stabilizers which typically work with cement. The reason is, I would say it is not very clear, because most of the companies would say that addition of cement would provide you the right kind of pH or right kind of environment, and that activates the stabilizer. What is the role of CCS? To be very honest, this is not even clear to the suppliers, because whatever strength you are getting, it is from the cement side. That is what my understanding is. No documentary evidence to support the claims, and the cost is significantly higher compared to the conventional stabilizers. You do a payment with a cement and you do a payment with a CCS, the cost is going to be significantly different. And why we should not use only commercial stabilizers, why to go with a commercial stabilizers at all, apart from the business economics. The other technology is the warm mix asphalt. Obviously, hot mix asphalt, we produce the mixes at high temperatures, and because of the environmental concerns, there are certain even regions also where the paving window is short. You cannot even heat the mixes to a high temperature. So there is an alternative, which is the warm mix asphalt technology, wherein we use certain additives and produce the mixes at a lower temperature. It is not cold mix where we use an emulsion and we also compromise on the quality of the pavement. Here we are using a warm mix, producing the mixes at a lower temperature, compacting them at a lower temperature, but without compromising on the quality of the pavement that is produced or the mix that is produced. The quality would be same as a hot mix. The only advantage is that you are using an additive, so you'll be producing and compacting the mixes at a lower temperature, and typically the temperature drop should be more than 30 degrees or lower, so we call them as warm mix asphalt. And obviously when we produce the mixes at low temperature, compact them at a lower temperature, we do understand that there are a lot of environmental benefits that we can get out of it. Because in the production and during the mixing of the material, it is the maximum amount of emissions that are generated, and if we control them, then we can reduce the emissions to a significant extent. A comparison of hot mix asphalt and warm mix asphalt. Hot mix asphalt typically we produce at a temperatures from 150 to 180. Warm mix asphalt typically at a temperature of 110 to 140 or 150. Additives are needed. In hot mix asphalt, we do not require any additives. Warm mix asphalt, yes, additives are needed, and why they are important, I'll discuss later on. Energy consumption in the case of hot mix, and emissions also high in the case of hot mix, but in the case of warm mix asphalt, the emissions are also low and the energy consumption would also be low. But yes, they do require additives. This is an additional thing that we have to add in the during the production of the mix, that you have to add certain additives in the hot mix. Why they are important? Because since you are producing the mixes at a lower temperature, and when you are compacting it at a lower temperature, it is possible that the compaction would not be achieved if you are compacting a hot mix at a low temperature, because the temperature has a very big effect on the compaction of the mix. So you have a compaction range beyond which, if your mix cools down, you might not be able to achieve the required compaction, or even the density would be, or you might have to apply larger compactive effort. So what hot mix asphalt do, they basically play with the viscosity of the binder. So there are additives which we add, and these additives can be classified into different categories: organic additives, chemical additives, and foaming processes. Wherein, like organic additives, they basically reduce the viscosity of the binder. Once the viscosity of binder is reduced, you are able to coat the aggregates easily at a lower temperature, and you are able to compact the mix at a lower temperature also. Chemical additives, they basically work at the interface of the aggregate and binder interaction, so they reduce the frictional forces between aggregate and binder, and then because of this increased lubrication between aggregate interface and the binder, you are able to compact the mixes at a lower temperature. And foaming is basically where a water is injected into the heated binder, and because of this, it basically expands in volume, and because of the increased volume and the increased surface area, you are able to coat the aggregates easily, and the compaction and production can be achieved at a lower temperature. Warm mix design is same as it is done for hot mixes, only that you need to check for the compactability, and compactability we check through the ratio of the air voids. These are some of the test sections which have been laid. CRA laid the first test section of warm mix asphalt in the year 2009 at the industrial air Bhavana, where the temperatures were almost more than 30 degrees with the warm mix asphalt. Again, in Godhra, State Highway 5, this warm mix asphalt was used. Even on the Ringa-Sikar road, this was used. And in Jammu bypass, this laying of hot warm mix asphalt was done, and this was done at a night time when the temperature was close to 1 to 2 degrees. At such lower temperatures, it is difficult to lay the hot mix asphalt, and even the guidelines would also say, even ministry book also says that when temperature drops to less than 10 degrees, bituminous works are not being carried out. But with the usage of warm mix additives, we are able to compact and lay the mixes even at lower temperatures and were able to achieve the required densities. Some insights like what additives to be choose, it has to depend on the user need. Sometimes we have to add anti-stripping agents with warm mixes because since you are producing the mixes at a lower temperature, so you are heating the aggregates to significantly lower temperature, it might be possible that there is some moisture in the aggregates, so you have to have some anti-stripping agents. Sometimes that might also be needed. Proper mix design has to be done, and you need to establish the mixing and compaction temperatures in the laboratory. We do not take it directly from the viscosity temperature plots. Pavement recycling, when we talk about the pavement recycling, it means using the existing pavement that is available and reusing it. That is basically the recycling. So whatever we get from the pavement, existing pavement, that is basically called as the RAP, that is the reclaimed asphalt pavement. And the addition of RAP would gives you a lot of savings in terms of the material, and you can take advantage of the available bitumen in the RAP material. So there are many advantages, economic and environmental advantages. The recycling can be divided into two types, hot recycling and cold recycling. And again, these two types can be further divided into two categories like in plant and in place. So hot in plant, basically hot in, and these are the depths of recycling which have been recommended by IRC 120 2015. There is a full-fledged code on recycling, and this is being used very commonly on many of the routes in the country. But there is certain restrictions which have been imposed by the code, like you cannot use more than 30% RAP in the construction process, and there is only a limited depth of the reconstruction that can be done through the recycling. Like cold in situ recycling 75 mm, hot in situ recycling is only the surfacing layer, that is 50 mm, cold in plant is 100 mm, and hot in plant is only 100 mm. Only in the case of full depth reclamation where the failures or deficiencies can be up to the granular basis level, we have to go with the full depth reclamation. So this is the chart where you can select like what type of recycling method would suit to your requirement. Hot in place is basically like you heat the material using these radiant heaters. You heat the material, mill it out, again on site it is being mixed with the fresh material, and then it is again relayed. In the hot in plant recycling, you take the material to a centralized plant, there you do the mix design, and then you again bring the material to the site and then you recompact it. But the condition is that you cannot use more than 30% RAP. If it is done in a cold, with using a cold binder which is emulsion, sir, I'll require 5-7 minutes more. If it is done using an emulsion on site, then it is basically a cold in place recycling, and if it is done through a emulsion or foam bitumen plant, then it is basically the cold in plant recycling. But the restriction is again, you cannot use more than 30% of the RAP material. Stockpiling of RAP is very important to minimize the moisture. I'll skip this. Yeah. The guidelines is placed a restriction that you cannot use more than 30% RAP because there are problems with more than 30% RAP. There could be early cracking, durability is affected, so revealing could be an issue with the pavements which have been laid with more than 30% RAP. The material, the RAP material that we get from the milling process, that also has variable binder characteristics, and it also has the variability in the gradation. And voids and BMA, they also restrict the usage of the RAP that can be used during the mix design process, because RAP is bit fine material. So if you try to increase the percentage of RAP, you will not be able to meet the mix design requirements of the required voids and the BMA ratios. So for this reason, there have been restrictions that you cannot use more than 30% RAP. Multiple sources RAP are not applicable or not used. It is better to fractionate the RAP into different fractions. But typically studies have been done wherein people have tried using more than 30% RAP. Even CRA has laid sections wherein up to 60% of RAP has been used. And when you go for a high quantity of RAP, you typically have to use the rejuvenators or the recycling agents. They basically restore the properties of the old binder. And you have to identify the dosage of the RAP using a proper mix design in the laboratory. Number of rejuvenators are available. So I have a list of like 40-45 rejuvenators. Different weights of rejuvenators would have to be worked out in the laboratory using a proper mix design. But this is only a limited number of rejuvenators I have compiled. There are many more available in the market. Which rejuvenator to choose, it will depend upon the type and amount of wrap material that you're using, and is chemical testing needed? Yes, to understand the mechanism of rejuvenation, it is better to do the chemical testing. Waste plastic, I'll quickly move through waste plastic because we know waste is a concern and there are issues, and since waste plastic has got polymers into it, so we typically use waste plastic for improving the characteristics or the performance of the mixes. Dry process and wet process are the two processes through which waste plastic can be added into the road construction. Dry process typically which IRC has published the guidelines, but again one has to take precautions that not all type of waste plastic are allowed and not all sizes of waste plastic are allowed. The guideline says that you can use the waste plastic which are between the size from 2.36 mm to 600 micron size. Dust and impurity should be less than 1% and maximum 8% of waste plastic can be adopted in the hot mix plant in the hot mix, and also this has to be confirmed and this has to be done through a proper mix design. There are different types of plastics, but the guidelines only recommend the uses of LDP, low density polyethylene, high density polyethylene. Other types of waste plastics have not been as of now recommended in the guidelines, but people have been doing studies and they have been doing research on using different type of waste plastic in the road construction process, and for this one has to do a lot of checking of the waste plastic, and there are different tests which one can do. Like for organic contamination, we can do the FTIR, Fourier transform infrared spectroscopy. For blendability, we can do a differential scanning calorimetry. Purity ke liye we can do a thermogravimetric analysis. Hazardous activities is GCMS. Processability, melt flow index. Storage stability, density check. For solubility, we can use the Hansen solubility parameters, polarity and leachability. All these have to be tested. The issue is that we do not have a proper waste collection system, so we have to make it a waste collection system so that we can, from the waste, we can have a proper. CGBM is one technology where basically it's a skeleton of the open graded mix, and then you basically add the grout into the mixture. We have the basic structures of the bituminous layer, and then you pour the grout and you mix the fill these voids. So typically, if I show the video, you can see that here the basic asphalt layer has been laid, and then the slurry has been pushed into the voids of this layer, and these basically will do the full grouting of the pavement. Recently, IRC has published a recent guidelines on IRC-SP 139/2023, which is on high performance mixes. And they use basically high performance binders which are very stiff and they have high resilient modulus. The idea is basically to have high modulus binders so that you can actually reduce the overall thickness of the pavement. So if you do a comparison of the design for 130 ms for different conventional mix and the high performance mixes, you will see that we can reduce some almost 30 mm thickness of the total construction of the pavement. Perpetual pavement is something which is designed for almost more than 50 years. So if you can provide a really thick asphalt pavement so that it does not have any fatigue cracking in it, so that is basically a perpetual pavement. And industrial waste, in the morning, Honorable Minister Shri Gadkari ji talked about the availability of good quality materials. So CRA has done extensive work on industrial waste, and IRC has also published a guideline, IRC-SP 132, wherein different industrial waste have been allowed to be used in the road construction process, but CRA has done a major contribution to that particular code, and also we have been laid trial sections using these different waste materials. So fly ash is one. There are different case studies. Copper slag is also, we have done a test section on tuticorin. Gerofix is also we have done on SH9. Phosphogypsum is also being done in Odisha, Paradip Phosphates Limited. Municipal solid waste, the Ghazipur waste that Minister Ji was talking about in the morning. So CRA did the initial study for utilization of this municipal solid waste into the road construction process. And steel slag, obviously, I'm sure that all of you must have heard about the usage of steel slag because this has been covered in the social media a lot in these days. So for the first time, we have constructed a pavement using processed steel slag. No aggregates were used in any of the layers in the road construction, and this has been laid on NH also, and this has been laid in the Arunachal Valley, in Zero Valley in Arunachal Pradesh, through with the help of BRO, and this has been laid there also, and this pavement has been performing extremely fine. Just 2 minutes, sir. We, like Nirmal ji told you that there is a IRC accreditation committee for accrediting new product, but my only appeal is that there is a lot of fascination about using the new technologies. Though IRC accreditation committee provide the usage of these materials, they provide the certificate that the material is good, it can be used on the pavement construction, but that is only on trial basis. But the problem is that the agencies or the companies, they use it on a large scale, or they construct kilometers of road using that certificate. So it is my humble request to user agencies and departments that they need to be more vigilant, more careful, that if it is on a trial basis, so it should be used only on trial basis, and large scale implementation should not be, rather it should be avoided. So thank you for your kind attention, and I'm sorry like I exceeded the time. Thank you so much.
Thank you. I know that because of the limitations, time limitations, we had to cut short a 40-minute presentation to 20-25 minutes. But anyway, though we have already overshooted, but still we will have a couple of questions. Some of the comments, in fact, there is no question, but these are all comments which we have received from some of the audiences. And one student says that it is only one-way conversation. So that student, if he has any doubt, I think he can ask now a question, because now the floor is open for questions. Otherwise, others are comments that this kind of seminar should be held more frequently. These are all very informative, and that kind of comments are there. Now we'll take a couple of questions from the floor on any of the panelists or any of the speakers, experts, because we have to try to cover all the aspects, pavement, flexible pavement, bridges, new technologies, compaction, and rural roads. So any question from the floor? I think everybody is asking for tea. It's a tea break. Already we have overshooted tea time also. Yes, please. You can identify yourself and then you can ask question.
हेलो, सभी को नमस्कार सर। जो अभी प्रेजेंटेशन हुआ फ्लेक्सिबल पेमेंट का, उसमें सर क्वालिटी ऑफ बिटुमेन, क्वांटिटी ऑफ बिटुमेन, ग्रेडिंग के बारे में सर, हार्डनेस और टफनेस जो अदर एलिमेंट्स हैं सर, उसके बारे में सर कोई स्पेसिफाइड नहीं बताया गया है, तो सर उसके बारे में क्या?
Would like to?
So typically, whatever bitumen we use, whether it is a conventional bitumen, so we have to see that it meets all the properties as per IS 73. And if it is a modified binder, it has to meet the requirements of IS 15462/2019. So all those tests we do, and then we check that whether the material meets the requirements. Only then you use the material for road construction. There is as such no test for hardness or toughness for bitumen. I mean,
but the effect, the durability of the and the age of the flexible pavement, all these factors also have some importance or not?
Sir, binder, okay, I got your point. So binder, basically, you are talking about the aging of the asphalt.
Sir, I am talking about the all elements of the flexible pavement, but you have covered some elements.
Okay.
मेरा क्वेश्चन आप समझ पा रहे हैं? आपने जो है इस अपने लेक्चर में जो कवर किए हैं, कुछ पॉइंट कवर किए हैं, लेकिन जो ऑल अदर्स एलिमेंट हैं फ्लेक्सिबल पेमेंट के, उनकी क्या भूमिका रहेगी? ये मेरा क्वेश्चन है।
I'm still not clear, sir.
मेरा ये क्वेश्चन है सर कि आपने जो है टेम्परेचर्स के बारे में अदर एलिमेंट्स कवर किए हैं, तो मेरा ये कहना है कि जो क्वालिटी ऑफ बिटुमेन, मतलब क्वालिटी ऑफ बिटुमेन की जो क्वालिटी है, डिफरेंट टाइप के बिटुमेन्स होते हैं, उनका क्या रोल रहेगा, और क्वांटिटी ऑफ बिटुमेन, परसेंटेज ऑफ बिटुमेन, एंड ग्रेडिंग ऑफ एग्रीगेट, एंड टफनेस ऑफ एग्रीगेट, हार्डनेस ऑफ एग्रीगेट, इन सब एलिमेंट्स का क्या रोल रहेगा जो आपने लेक्चर्स प्रेजेंट किया है?
Sir, whatever material we use in the road construction process, we have to see that it meets the requirements as per the guidelines. So if you are using the aggregates, so there is a requirement of the aggregates that it has to have impact value, it has to have a certain stripping value. So all those properties we test, and once the aggregates meet the requirements, only then we allow the aggregates to be used in the road construction process. Similarly, for the bitumen, we check the binder and then we allow it to be used in the road construction process. Also, like when we do a mixed design, so we have to see that we do a proportioning of the aggregates from different aggregate fractions, and then we do a proper mixed design and see what is the optimum binder content that we are getting. And the same is being laid on the site.
Thank you very much.
Yeah.
Hello. Hello. नमस्कार सर जी.
हाँ, yes please.
सर जी, एक बिटुमिनन सोर्स जो है हमारा, उसके रिगार्डिंग एक डाउट है सर हमें. जो NH में सर्कुलर है सर, अभी लास्ट ईयर अगस्त 2023 में, उसमें सोर्स में चूँकि इंडिया में बिटुमिन की बहुत स्कैर्सिटी है. अभी इसी साल इकोनॉमिक टाइम्स का एक लेख था, उसमें 7,000 टन जो प्रोडक्शन होता है इंडिया में यूज़ होता है, उसमें 3,000 अराउंड तो इंपोर्ट होके हम मंगाते हैं. आज ही के न्यूज़पेपर में आज एक शायद उल्लेख किया था कि बिटुमिन सोर्स हम सरकारी कंपनियों से हम बिटुमिन परचेस करके उसको हम वेरीफाई कराएं. तो एक तरफ NHI का स्टैंडर्ड है कि वो इम्पोर्टेड बिटुमिन को अलाउ कर रहे हैं, और हम लोग अभी सरकारी कंपनियों की ओर जोर दे के, जो कि हमारे पास बहुत स्कैर्सिटी है जिसकी, तो हम लोग उसकी ओर जा रहे हैं. तो आप लोगों के लिए जानना चाहता हूँ, एक कॉमन राय, एक कॉमन प्लेटफॉर्म हो सकता है क्या सर सोर्स के रिगार्डिंग, बिटुमिन सोर्स ओनली?
I think there were earlier restriction in the 2018 circular of ministry on NH works. It is only refinery produced bitumen will be allowed. But that circular has been superseded in 2023, and even Ministry of Road Transport guidelines says now, all even import of imported bitumen is also allowed, subject to all the tests being done. So now there is no restriction as far as NH works is concerned. NHI was already, because there is a huge requirement of bitumen. So, and our refineries are not producing to meet all the requirement. That is why we permitted now all the kind of bitumen. So, I think there is no other, what is your, for the specific question then?
Sir,
because we have allowed all the bitumen.
Sir, NH is allowing imported bitumen, but state government like PWDs and our PMGSY are not allowing imported bitumen.
State government, if any restriction is there still, you have any circular for that?
सर, आज के पेपर में दैनिक भास्कर में ये लेख है, और अभी लेटेस्ट
मेरा साहब, would you like to clarify?
सर, ये ठीक कह रहे हैं. कल मंत्री जी का प्रेस कॉन्फ्रेंस था, तो हमारी प्राथमिकता तो गवर्नमेंट रिफाइनरी से शुरू से रही है, हमारे एग्रीमेंट में कंडीशन है. लेकिन ये भी सच है कि मिनिस्ट्री ने गाइडलाइन अगस्त 2023 में निकाली है, SOP जारी की है. तो हमारे यहाँ ऐसी कोई शॉर्टेज की अभी कोई प्रॉब्लम आई नहीं है स्टेट PWD में. यदि भविष्य में कोई शॉर्टेज आती है तो हम गवर्नमेंट ऑफ इंडिया की गाइडलाइन और SOP जारी करेंगे. अभी कोई शॉर्टेज एज सच फील्ड से नहीं आई है.
I think this is the reply you have heard here.
जी सर. Okay, sir.
Maybe one last question, anybody?
Sir, procuring of bitumen from private or private refinery is big challenge, because we cannot control the quality of bitumen from the private suppliers. That's why state governments have restriction to procure the bitumen from the government refinery only. That is the reason. It is a very big challenge to quality control bitumen from private suppliers.
Yeah, there was a real concern, and we have asked. In fact, there were meetings in ministry with all the refineries and all the manufacturers, and we wanted that strict quality control measures must be taken, not only from the private but government also, because there is a pilferage of bitumen. There is even the adulteration of bitumen even from the states where no private bitumen is allowed. So the quality is real concern, and we have issued SOP now. And based on that SOP now, if they meet the requirement, that is why it was allowed from the ministry side. But state government also can, I mean, if there are stringent quality control measures, if they also have some SOP kind of thing, and if there is a shortage, then I think you can review your decision in case there is a demand-supply gap. Yes, Professor Reddy.
This roller which you are talking about, roller works as an intelligent compactor or it only verifies the number of passes?
सर ये जो टेक्नोलॉजी कैटर करती है वो नंबर ऑफ पासेस को भी कंट्रोल करती है, एड्रेस करती है. उसके साथ इंटेलिजेंट कॉम्पैक्शन मीटर वैल्यू जो हमारी होती है ICMV, उसको भी जो सेंसर्स होते हैं वो सेंसर स्ट्रिंग बेस्ड सेंसर्स होते हैं. वो सेंसर के बेसिस के ऊपर जो कॉम्पैक्शन वैल्यू हम फील्ड की डेंसिटी से एक बार जो हमारा अथॉरिटी इंजीनियर चेक करता है उसके बेसिस पे वो वैल्यू हमारी 12 आ गई तो 12 को हम मान के चलते हैं और 12 जहाँ जहाँ पे भी अचीव होती है वो स्पॉट्स उसमें रिकॉर्ड हो जाते हैं जो हम इस सॉफ्टवेयर में फीड करते हैं. ये टेक्नोलॉजी के अंदर है, अपना प्रावधान उस सॉफ्टवेयर में है सर.
ओके, थैंक यू.
एक्सक्यूज मी सर.
सर
सभी को नमस्कार सर.
सर I have one question. Regarding bitumen, modified bitumen, we are enforcing that the wearing cost must be by the modified bitumen. But on the other hand, we are restricting that the modified bitumen cannot be prepared at the site. It is a big challenge for the contractors who are doing huge work to get the modified bitumen from the private vendors. And they are having a lot of complication, adulteration on the way, as well as large type of equipments with the stirrers and all these are requirement. So I think we should allow the modified bitumen to be prepared at the site also.
I think there are certain test requirements, DSCR and MCR. So these test requirements, these facilities are mostly not available at site. If you see the quality, because it has to meet all the quality requirement. So there were discussions, even there was ministry group I was heading that particular group where we were to review that what kind of quality control tests should be there even for modified bitumen. But unfortunately the test equipments are costly and not every contractor can procure that test equipments. That is why we had to restrict that, because that unless these tests are done, modified bitumen quality cannot be ensured. So if the facilities are available for large size projects, more than 500 crore and all, now we have made compulsory that they should have this test facility at site by all the manufacturers or those who are suppliers. They should make it available at site. Then it can be allowed. But at present that facility is not there. That is why there is a restriction. Yeah.
But sir, many contractors are agreeing. They want that they can easily produce the modified bitumen there also.
But one or two contractor if they have, but it cannot be generalized through a policy. If there will be enough contractors, for large projects, we can also review. In fact, there was a proposal from our group that for large size project, we make it compulsory that all these testing facilities should be available at site. But then there will be, issues that which contractor is making it available, which contractor is not making it available. So a policy circular cannot be issued on one or two contractors basis. So in near future, if we find large number of projects, every contractor or most of the contractors are equipped with these testing facilities, then it can be reviewed. I think
शेड्यूल डी में कहीं और मतलब ईपीसी की बॉडी में या हैम की पूरी बॉडी में तो नहीं डाल सकते हैं, बट बेसिकली अगर उसको डालना है तो शेड्यूल डी में बी में भी हम चेंज करते हैं, सी में भी चेंज करते हैं. तो शेड्यूल डी ईपीसी कॉन्ट्रैक्ट के शेड्यूल डी में हैम के कॉन्ट्रैक्ट के हैम जो डॉक्यूमेंट है उसके शेड्यूल डी में ये जो 3-4 पन्ने के नोट हैं, जो टेक्स्ट है, ये टेक्स्ट जिसमें कि 3-4 चीज़ें हम एक्सप्लेन करते हैं वो बिल्कुल डाल सकते हैं. और डाल के अच्छा उसमें स्पेसिफिकेशन ना बता के हमको जो रिजल्ट चाहिए, हमको जो सर्विसेज चाहिए, वो सर्विसेज उसमें मेंशन करेंगे सब.
सर ये सर वाइट टॉपिंग चैप्टर में इसका सेपरेशन मेम्ब्रेन्स का क्लियर नहीं हुआ सर.
नहीं, वाइट टॉपिंग पे आप अभी देयर विल बी ए स्पेशल लेक्चर ऑन वाइट टॉपिंग. सो आई थिंक वंस यू हियर दैट लेक्चर or the presentation, then you can ask your question if there is any further clarification required. I think before we close the session, I will request my co-chair, Mr. Bosi, to sum up whatever were the 4 presentations in a brief way.
सर नमस्कार सर. बहुत चारों लेक्चर न्यू टेक्नोलॉजी के ऊपर बहुत अच्छे हुए. जो हमारे प्रदेश को नई दिशा देंगे सर। पहला लेक्चर था PMGSY ऑन इम्प्लीमेंटेशन ऑफ न्यू टेक्नोलॉजी बाय डॉक्टर I.K. पटेरिया सर। जो मैक्सिमम इसमें जो FDR टेक्नोलॉजी जो हमारी एग्जिस्टिंग रोड है उसको किस प्रकार से हम उसको न्यू टेक्नोलॉजी से यूज़ करके एग्जिस्टिंग मटेरियल है उसका यूज़ करके हम अच्छे से अच्छी रोड को बना सकते हैं। आपने बताया कि PMGSY में 7.5 लाख किलोमीटर की रोड हैं, एग्जिस्टिंग रोड है। उनमें से एग्जिस्टिंग रोड उन्होंने 1 लाख किलोमीटर से अधिक सड़कों को रिक्लेम से मेथोडोलॉजी से बनाकर उसको प्लानिंग की है, जिससे कि नई जो एग्जिस्टिंग रोड है उसको अच्छे से अच्छा यूज़ किया जा सके। इसमें विशेष तौर पर उन्होंने जो टेक्नोलॉजी का यूज़ किया है FDR टेक्नोलॉजी, वाइट टॉपिंग, दोनों के बारे में बहुत अच्छे से ब्रीफ किया है। FDR टेक्नोलॉजी और वाइट टॉपिंग में एक विशेष तौर पे हमें सावधानी रखने की आवश्यकता है। जो एग्जिस्टिंग सरफेस में सेटलमेंट नहीं होना चाहिए, यदि वहाँ सेटलमेंट होगा और वो सबग्रेड हमारा फेल्यूअर की स्थिति में होगा, यदि ये टेक्नोलॉजी का यूज़ करेंगे तो वहाँ कहीं ना कहीं हमें क्रैक्स आएंगे, सेटलमेंट होगा। तो ये हमें ध्यान देने की आवश्यकता है। इसी प्रकार से हमारा जो सेकंड लेक्चर भी बहुत प्यारा था, जिसमें मशीन गाइडेंस कंट्रोल सिस्टम के बारे में विवेक जायसवाल साहब ने बहुत अच्छे से ब्रीफ किया। जो अभी हमारे जो फ्लेक्सिबल पेमेंट हो या रिजिड पेमेंट हो, दोनों भी एक ही समानता है कि अलग अलग लेयर में हम कंपेक्शन करते हैं। कंपेक्शन करके मार्गों के लेयर कंपेक्शन करके उसकी FDD से चेक करते हैं कितनी FDD से आना चाहिए। तो अब उसके अंदर नई नई टेक्नोलॉजी के हिसाब से नई मशीन आई है, नई मशीन के हिसाब से वो ऑटोमेटिक उसमें फंक्शन देकर उसको कंपेक्शन किया जा सकता है, जिससे कि हमारी स्पीड जो पहले हम 1 किलोमीटर बनाने में यदि हमें 5 दिन लगते थे तो उसको कम से कम 3 दिन में ही हम उसको रोड को बना सकते हैं। इतनी स्पीड से काम टेक्नोलॉजी के साथ काम होगा, उसमें ड्रेनेज सिस्टम से लगाकर कैम्बर का प्रोफाइल को ये बहुत अच्छे से हम इसको मेंटेन कर सकते हैं। तो इसी प्रकार से इस टेक्नोलॉजी के बारे में भी बहुत अच्छा है हमारे इंजीनियर के लिए, यहाँ जो भी सीखेंगे और वहाँ पर जाकर और भी अच्छे से एक्सपीरियंस लेंगे। सर तीसरा लेक्चर था आलोक पांडे साहब का, न्यू इक्विपमेंट मशीनरी टेक्नोलॉजी एंड यूज ब्रिज प्रोजेक्ट प्रिपरेशन एंड कंस्ट्रक्शन। सर ये जो ब्रिजेस हैं अभी तक हम जहाँ तक हमारी मानसिकता है कि M40 ग्रेड से ज़्यादा नहीं और 100 ईयर से ज़्यादा हम इसकी एज नहीं मानते हैं। अब पांडे साहब ने बताया कि हमारी इसकी ग्रेड ऑफ कॉन्क्रीट M200 और उसकी एज हम 300 ईयर्स तक की ले जा सकते हैं। और ये जो ब्रिज बनने के साथ इसमें अलग अलग स्ट्रक्चर स्पान अरेंजमेंट से लगाकर एस्थेटिक व्यू देना और आर्किटेक्चर व्यू देखकर उसको कंक्रीट में दिया जा सकता है। उसके साथ ये भी है अलग अलग स्पान अरेंजमेंट भी हम कम से कम 1 किलोमीटर से ज़्यादा के स्पान अरेंजमेंट हो सकते हैं। और इसके साथ यह भी बताया कि प्री कास्ट से हम फाउंडेशन भी बना सकते हैं, सब स्ट्रक्चर भी बना सकते हैं और सुपर स्ट्रक्चर भी कास्ट करके कर सकते हैं। तो ये बहुत अच्छी फास्ट टेक्नोलॉजी के साथ हम काम को कर सकते हैं। इसके साथ में आपने अवगत कराया। इसके साथ अभिषेक मित्तल साहब ने भी बहुत अच्छे से न्यू मटेरियल एंड टेक्नोलॉजी फॉर कंस्ट्रक्शन मटेरियल्स ऑफ फ्लेक्सिबल पेमेंट के बारे में, ये भी पटेरिया साहब ने जो हमें बताया है कि फ्लेक्सिबल पेमेंट FDR टेक्नोलॉजी और वाइट टॉपिंग से रिलेटेड ही मटेरियल का यूज़ किया जा सकता है और उसको किस प्रकार से मैक्सिमम मटेरियल का यूज़ करके हम प्रदेश की सड़कों को बहुत अच्छा कैसे कर सकते हैं। इस दिशा में बहुत अच्छा कदम है। ये हमारे प्रदेश के लिए माननीय मंत्री जी के द्वारा बताया गया कि हमारे मैदानी अधिकारी को नई टेक्नोलॉजी के बारे में उस प्रशिक्षण दिया जाएगा, जिससे कि हम बाहर यहाँ के जब तक प्रशिक्षण नहीं लेंगे तो नई टेक्नोलॉजी के बारे में हमारा ये डर खत्म नहीं होगा। डर खत्म करने के लिए हमें प्रशिक्षण की बहुत आवश्यकता है, जिससे कि हम प्रदेश के हमारे इंजीनियर के साथ बहुत अच्छा काम कर सकें नई टेक्नोलॉजी के साथ। थैंक्स सर।
धन्यवाद सर।
Thank you for, I thank my all the 4 expert speakers for doing full justice with the topics which they have presented, and even the floor intervention was also excellent, but the time limitations was there, otherwise we would have taken some more time and more questions we could have answered. So thank you very much once again for this excellent session. Thank you.
1 minute more sir। प्रथम सत्र के समापन पर मैं श्री निर्मल साहब से रिक्वेस्ट करूंगा कि वे श्री जायसवाल साहब और पांडे साहब को मार्क ऑफ ऑनर मोमेंटो देकर अभिनंदन करें। श्री निर्मल साहब। सेशन के को चेयरपर्सन श्री बोरासी साहब से रिक्वेस्ट है कि श्री पटेरिया साहब और डॉक्टर अभिषेक मित्तल का मोमेंटो देकर अभिनंदन करें। प्रेसिडेंट आईआरसी श्री पीपरी साहब से अनुरोध है कृपया मंच पर आएं और निर्मल साहब का और बोरासी साहब का मोमेंटो देकर अभिनंदन करें। श्री के पीपरी साहब। थैंक यू सो मच सर। यहाँ पर हम प्रथम सत्र का समापन करते हैं। 10 मिनट्स का टी ब्रेक है, देन वी विल रीअसेंबल हियर। थैंक यू सो मच। थैंक यू। हाई टी का अरेंजमेंट एग्जैक्टली इसके from Ultratrek Cement, Shri Nagesh Puttaswamy, you are also requested to come over the dais and have a seat, please. Messrs. Natural Simeco Private Limited, Ms. Pallavi Barjatya, you are also requested to come over the dais and have a seat, please. Please. Now I will request श्रीमान S.R. बघेल साहब, इंजीनियर इन चीफ बिल्डिंग मध्य प्रदेश लोक निर्माण विभाग, कृपया मंच पर आएं और आज के सत्र के चेयरपर्सन श्री के पीपरी साहब का पुष्पगुच्छ भेंट कर स्वागत करें। श्री अहिरवार साहब से रिक्वेस्ट है कृपया मंच पर आएं और को चेयरपर्सन श्री सूर्यवंशी साहब का पुष्पगुच्छ भेंट कर स्वागत करें। अब मैं सत्र के आगामी कार्रवाई के लिए श्रीमान के पीपरी साहब से अनुरोध करता हूं। थैंक यू।
On behalf of Indian Road Congress and Government of Madhya Pradesh, Pidaudi, I welcome all the presenters. There will be 5 sessions, on 5 topics in this second session. First, new material and technology for concrete and maintenance of rigid pavements by Professor M.A. Reddy, IIT Kharagpur, 20 minutes. Use of marginal material in road and bridges by Sri Satyendra Kumar, HOD retired, RPD, CRRI and consultant, 20 minutes. New material and technology for improving road safety by Dr. Samson Matthew, Director, NET, 20 minutes. Experience on white topping by Messrs. Ultra, Sri Nagesh Puttaswamy, 10 minutes. Repair of rigid pavements by Messrs. Natural Semco Private Limited, Mrs. Pallavi Bharti, 10 minutes. I request all the presenters to conclude within the scheduled time. I invite Sri M.A. Reddy to start the presentation.
Okay. Good evening. At the outset, I would like to thank IRC as well as PWD, Madhya Pradesh State, for giving this opportunity to just talk about the new material and technology for construction and maintenance of rigid pavement. So, of course, I'll also thank the chairman, co-chairman for giving me this opportunity, and also I'll stick myself to even less than 20 minutes so that others also will get opportunity. So today I'll be talking about short slab concrete pavements, which recently this concept was developed. It is nothing but white topping, but there is a difference between white topping and this. If you see the even IRC 76, it is mentioned that it is for low volume of national highways. But whereas for high volume roads, very high volume roads, so we recently developed a guideline which is called as short slab concrete pavements. So I'll be talking about this, followed by there are a few more where you can reduce the thickness of concrete pavements. Basically, that is the motto of any government's sustainability, cost reduction, faster in the construction, and safety. These are the 4 pillars for any construction industry, especially road industry. So in line with, I'll be just talking about this. So all of you know that there are different kind of concrete pavements. The first one is very popular, jointed plain cement concrete pavement, which we normally use with 3.5 by 4.5 meters of, that is what we normally follow. Now and then we extend we widen the concrete pavements, sometimes to 4 meters, even 4.5. But problem is, if you go beyond 4.5, you need for longitudinal cracking, which is not there in the IRC 58. Even IRC 58 is only meant for 3.5 by 4.5 meters. Anyway, that is a jointed plain cement concrete pavement, but there are other concrete pavements which are not that popular, except the last one, that is called self-heal concrete pavement, which PMGSY is using. But the CRCP, that is continuously reinforced concrete pavement, where you don't require any joints to be cut, but this is used in US and other places. So as I said that, India, we are using that JPCP very commonly. So now this JPCP, conventionally if you see for high volume road, the thickness will come around 270, 280. Even if you go for without shoulders, without tight shoulders, it may go to even 330. That was the example that you have given, we have got in IRC 58, that is for high volume roads. But is there any way where we can reduce this cost minimization, as I said? So there are some ways where we can use some innovative kind of design and the dimensions of the concrete pavement or arrangement between 2 concrete layers so that we can reduce the thickness. So one of them is short slab concrete pavement, which I will be dealing little detail. There are also bonded concrete pavements, which are also reduce the thickness of concrete layer. Also, there is a 2-lift jointed plain concrete pavements where you can use the marginal materials at bottom layer and superior materials at the top. So this is what the short slab. So short slab is nothing like a concrete pavement, but only thing is the size of the concrete slabs are less. It starts from 1 meter. Of course, 0.5 is too less. So 1 meter to 2 meter. So you can have normally practices. These are relatively new. Of course, a few urban roads they have started, but some of the expressways, of course, high volume roads also they have started. Of course, you will also see that there will be presentation from, I think, Ultratech on Nice Road. So it is 1 meter by 1 meter, 1.25, like square slabs, but also you can design as rectangular slabs. It is same as regular concrete pavement. Only thing is, we'll be cutting the joints at closer interval, at within 16 to 18 hours. That depends on the weather conditions. So bonded pavements means you will have a DLC and you don't put any plastic sheet. You just directly put another concrete layer. So you get a monolithic action. So with that, you can reduce the thickness of the concrete pavement. That is the second one. The third one is this one, two-lift concrete pavement, where the marginal materials, okay, are materials with very high coefficient of thermal expansion, marginal materials, even reclaimed concrete materials, all these can be put bottom layer, and top layer is a superior one. So where you can again reduce the construction cost, etc. So this is as I said, that this is a definition. And why these short panels will have less thickness? Because the regular concrete pavement, which has got a size of 3.5 by 4.5, they normally transfer the load with a slab action where you have a bending. Bending is predominant. Okay, that's why we check for flexural stresses or flexural strength. But when you reduce the slab sizes, what happens? It's a combination of the bending as well as compression. Bending as well as compression. So bending stresses are going to reduce. Even the temperature stress is also going to reduce. Okay, taking this as the philosophy, we can the design or plan for this kind of things. And the advantage of this one is you don't require any double bars, no tie bars except at construction joints. Okay, so you can save good amount of money. So keeping this as a criteria, there are different options that are available. Of course, this very recently, like 4 months back, there's one guideline release, IRCSP 140, where this kind of payments can be constructed on a new concrete, as a new concrete payment. That means you can have a subgrade, then CTGSB, DLC, and short panel concrete payment. Or you can also construct, we have given different options. You can also construct this as an existing bituminous payment. Like that's what we say, white topping. Or this guideline also says that you construct a DBM layer, a new DBM layer. Bottommost is granular materials, WMM, then DBM. Minimum thickness is 75 mm. Above that, you can go for a concrete pavement. So there are different options that are given where we can construct this kind of pavements. So what happens is you have lower stresses, then you get a lower thickness, okay? And as I said that replacements of slabs, if required, suppose these slabs are going to damage, 1 meter by 1 meter, there is a damage, you can easily replace it. But a regular concrete pavement, you have to break it, and it is a huge amount of money, and even the repairing, etc., is more costlier. Okay. So as I said that no double bars that are required, but here there's no performance. So we searched a lot of, because when we started this work, we searched many literature, we accept Chile and some countries, nowhere they have used this kind of payments. Anyway, somehow we don't know. But anyway, they are even, Europeans and US, they dislike the cracks. Like when you have joints, the joints will create noises, etc. But here, the width of joint is not conventional concrete pavement has a width of joint is 8 to 10 mm, but here it is 3 to 4 mm only. 3 to 4 mm joints are cut. Okay. So this is a concept of this thing. So you'll see that in a 4.5, the conventional slab, the load is distributed in a wider slab, but in that it's a compression, a combination of compression as well as flexure.
So thereby you can reduce the thickness. So you place this on a strong foundation, that is on a lean concrete, that is DLC, or DBM, existing bituminous layer. Only thing is we require 75 mm of it. So if it is badly damaged, you just mill it out, top layer, then you place this concrete. Of course, since we require this thing, you can use with and without the plastic sheet in between. Okay. So joints are cut at every 1 meter depending on the size. Okay. Only 1/3 depth is cut, not full depth. And here load transfer takes place because only 1/3 we have cut, so remaining 2/3 load transfer will happen. Okay. And there will be, because of this, there will be reduction in the thickness, etc. So, and as it looks like IRC SP73 white topping, but white topping, where if you see the design that what they did, because if you see the philosophy of regular concrete pavement, it is 3.5 by 4.5. The analysis is done on a single slab analysis. But when it becomes, slab size becomes lesser and lesser, when a wheel load is applied, adjoining slabs also share the load. That's why multi-slab analysis need to be done. Whereas in white topping, it's only single slab analysis is done. That's why this is more accurate. These guidelines are more accurate than white topping. That's why we went for ahead of that. So to start with, what we did was we constructed 2 test sections on a NH18, that is Baragura, Mohalia, in the state of Jharkhand. And one we have constructed an existing bituminous pavement. The other one, new layer of DLC, etc. were laid down. So this is a construction. So we tried different combinations, 1 meter to 1.5, 1.25, 1.75, 2 meter, different thicknesses. And these joints are sealed, unsealed, okay. And then we put a separate membrane layer, no layer, all kind of combinations were tried. This we have constructed in the year 2017 and is a very high volume road. It connects Jamshedpur. So this is what DBM. So DBM had only 7 meter width. We want 10 meters. So we widened this other portion. We constructed new DBM as well as, and we placed these things. So you can see that only end of the day, we require doubles, construction joints. Other than that, no doubles are required. Only thing is, the joints are to be cut. So you need to employ more number of machines. If you don't have more machines, you can cut at larger slabs, then you come to the required slabs. But only thing is, cutting should be completed within 12 to 16 hours. So this is a 2017. So recently we visited 2014 August, we were there. So almost 7 years served, and it is serving well. So I'm not going to. So we did a lot of testing on this. I'm not going to details of it because whether load get transferred or not, that is the main concern. So we use a falling weight deflectometer. We had our own falling weight deflectometer. We tried this. We found that the load transfer was very high. Even it did not drop down to 75%. Initially it was 95%. Max, we tested for 5 years, up to 2022 we tested. So the load transfer was very high in the sense, of course, in the order of 75%. And we did a lot of things, whether cracks really forms because we are cutting at 1 meter, no? Whether really cracks forms, we did not see that cracks, though we gave cracks at every 1 meter, 1.5, but cracks did not appear, so we measured all those things. We also did the curling studies, because these are the new pavements, how curling, temperature effect will be there. All these kind of studies were done. We also did the NSV, network survey vehicles, to see how the distresses which are forming on this. All these things are done, and based on this, I'm not going for designs, though I have written here. So we have done design using same principles of IRC 58, concrete road, but only thing is, we did multi-slab analysis. We took 9 slabs. When the load is applied on one slab, all adjoining slabs also, load gets shared. So we did that. So this is usually how we do the white topping, and this is a conventional concrete pavement. But this is what the analysis that we did. Like top-down cracking, bottom-up cracking, those who follow the IRC 58, they know about this. So I'm not going to details of it. So So we did several such kind of things. Okay, finally, when it comes to construction, okay, it is only M40 grade of concrete, only to reduce the like shrinkage cracks, etc. We used micro fibers over there. This is the dosage that we use. And you know, for a new layer of base course, DLC, only thing is this joint should match. That is the only concern. But if you have DBM, no issue. DBM can be of, so we write, of course, DBM is 75 mm. Sorry, we write 100 mm, 75 mm. So mixed design, everything is same because it's M40 grade of concrete. So all these things are available in guideline, which I'll show you at the end. So this is what we did the analysis. I'm not going for detailed analysis because it's already available in the guideline. So this is how we select the thickness of the entire slabs. Okay. And we have developed several regression equations. Okay, it's only not in charts, but regression equations. We also given the Excel sheets, okay, where you can put your slab size and get the thicknesses. So lastly, what we did, we compared. We compared with the design example that is given in IRC 58 2015. So IRC 2015 for certain traffic. The example, this is for with concrete shoulders. It is giving us 290 mm, 290 mm, but when I employ 1 meter by 1 meter, it is only 210 mm. But as I increase the slab size, the thickness is also going to increase. So ideally, I should go for 125, 150, like that is 1.5 by 1.5, 1.75 by 1.75, okay, or 1 meter by 1 meter. So this will reduce the thickness of concrete pavement. But if you see, if I go for without concrete shoulders, the thickness what was coming, conventional concrete pavement was 340. But whereas 1 meter by 1 meter to 2 meter by 2 meter, it is restricting from 215 to 280 mm. So there is a huge saving in the thickness, but also the double bars, tie bars are not required. Okay. Construction steps anyway, this is already there. I'm not going to details of it. So this is a guideline which was released in June 2024. This IRCSP guidelines for design of short slab concrete pavements for highways and expressways. So this is a sponsored project from National NHAI. So we thank NHAI. So whatever, of course, task that was given. So it is a laboratory test, okay, and a lot of analysis was done, and field test sections were constructed, field evaluation was done. So all is a complete kind of a thing. So this is available. So normally what we feel is white topping, yes, it works because white topping, the design is based on IRCSP 76. So that will work for low to medium kind of a traffic, but when it goes to very high volume of traffic, so these guidelines maybe can be adaptable. The second one, which of course I'll not speak much, I'll take only 2 to 3 minutes. So bonded concrete pavements. So bonded concrete is what? When the bottom layer is like DLC, okay? It is in wet, like you don't allow it to set fully, but what you do is you place one more layer called the concrete layer. So there will be a monolithic action. So because of this monolithic action, so you can reduce because you have a huge thickness which will come, but only thing is DLC will have a different strength, and the top layer of concrete will have different strength. So you'll have a monolithic action. With this monolithic action, you can reduce the thickness of the concrete pavement. This is in IRC 58, there is a clause that is given, okay, how to design this, based on that only, this concept has developed. So you need to do some calculations and finally say that. So what happens with this also, the concrete thickness is going to reduce. So for same, for same design example, the concrete thickness comes around 230 mm. Where the bottom layer is DLC, only thing is DLC, the 7-day strength is 15 megapascals, okay. The compression strength should be 15 megapascals because this will be designed based on a equivalent flexural strength. Anyway, I'm not going to details of it. So this is the design that they have given. And construction method, of course, this is likely to come as IRC guideline, specifications for bonded concrete pavements. design is already given in the IRC 58, that is JPCP, but only they talk about construction, other things. This is likely to come, so I have just taken from the guidelines which are likely to come up. The last one is two-lift jointed plain concrete pavements. Two-lift means the bottom layer. The DLC, even you can use with the marginal materials, okay? So we have worked on this, even we have published some papers also. So even if you use this kind of two-lift concrete pavements, okay, where the analysis is yet to come properly, so we are working on that. So two-lift concrete pavements, you can see that there is a subgrade. You can place a lean concrete of inferior materials because you don't require that superior materials throughout the width of the, thickness of the concrete pavement. And top layer only will be high quality grade of concrete, that is M40 grade of concrete. So with this also, you can do that. As of now, there are no ready-made solutions available, but we are working on it. We have just started some work on this. So we have also published one paper on this. So finally, to conclude, as far as the new materials and technology for construction and maintenance of rigid pavements are concerned, so the short slab concrete pavements is one of the solutions. Okay, either you can construct a new concrete pavement using this, or the existing bituminous pavement, which is distressed, also can be strengthened using this. Similarly, bonded jointed plain cement concrete pavements, two-lift concrete pavements also can be used, where when you adopt this, the thickness of the concrete pavement can be reduced. So all these here, something like how the stresses are being transferred, how the curling stresses are developed based on that, these concepts have been evolved, okay? So that's all. Thank you very much. So I just exceeded 1 minute, sorry. Okay, sir.
Thank you very much, Dr. Reddy, for your nice presentation. Now I request Satyen Kumar ji to start the presentation on use of marginal material in road and bridge construction.
Honorable Chairman, sir, Co-Chairman, speakers and fellow delegates. First, I would like to thank IRC and MPPWD for the invitation. The topic is use of marginal materials in road and bridges, both flexible pavement, rigid pavement and bridges. First, what we mean by marginal material? Means the properties of the material on the margin of the specification. Say between 10 to 20% this side or that side. It may be sometimes better, but which is not required on the other side also. There are different names. We can call it resilient material, we can call it sustainable material, we can call it manufactured material. So different code says different meaning. So first, why we need marginal material? What is the advantage? If you use local material, so transportation cost will be saved. If we use waste material, land we can save. If we use alternate binder, we can save energy also. If we use recycled material, whatever energy already we have spent, that we are using. So these are the things. What are the marginal material? If you see both sides, one side is for a concrete road and bridges, left side is for asphalt pavement. Those parts which I have covered, that I have not taken here. Like in the case of concrete road, fly ash, slag, recycled material, iron slag, chrome slag, zero fix. There are 3 code IRC code. Mostly I will cover the IRC code covering minimum quantity required and what is the thickness should be required. These are the point I will cover in the presentation. There is IRC 120, it is already covered by Abhishek Mittal sir. He has talked about FDR. In a concrete road, FDR is a full depth repair. In asphalt pavement, it is a full depth recycling. There are 2 different meanings. In rigid pavement, the FDR means repair of full depth PQC only. Otherwise, in asphalt, we can say. So here, if you are using hot in plant, hot in place, cold in plant, cold in place. Only hot in place, 100% you can do. But all other three cases, the value given is 30 to 50%. Generally, 30% is preferred. If your milled material is better, it do not contain any very fine particle or foreign particle, then we can go 50 also. Regarding, in the last position, somebody was asking regarding bitumen and other thing, so I will spend 1 minute actually. Earlier we were using, sir, VG10 grade bitumen, means 80-100 bitumen. This we were doing testing at 25 degrees centigrade. It was not stipulating with the field condition. We shifted from penetration grade to VG grade, viscosity grade. Viscosity is tested at 60 degrees centigrade for VG grade, and for PMB we test for 135. But after that, what we found in Rajasthan, the pavement temperature was found 80 to 90 degree. Then we shifted from PMB, PG grade, PMB, then PG grade bitumen also. So this is the chart. This will show you which type of bitumen. Now at present, we have to see what is the temperature of the pavement. Based on the temperature of the pavement, this circular is 19th April 2024. What is your traffic? 10 MSA, 5 MSA, 20 MSA, 150 MSA? What should be the base course? What is the, everything is given here. Regarding the gradation, your question was the basic principle in the design of flexible pavement layer, whether it is a bituminous layer or a lower layer. Thickness of any layer shall not be less than 2.5 times the nominal size of aggregate. In the revised Morse book, we have put 3 now. So sixth revision is under consideration. In case of concrete, any structure, whether rigid, flexible, concrete road or a bridges, any section shall not be less than 4 times the thickness in the case of concrete structure. Coming to the marginal material, we have 4 codes. First is IS 383. IS 383 specify use any material waste, provided it should have 4 technical specifications. Specific not less than 2.1. Water absorption not more than 5. How much percentage? It is also given. For lean concrete, 100%. For PCC, 50%. For RCC, 25%, up to M20 grade only. You can use for coarse aggregate, you can use for fine aggregate. Coming to IS code, IRC, 3 codes are there. IRC 121, construction demolition waste. IRC SP 121 on slag, and IRC SP 132 on all industrial waste. So whatever the percentage given there, this code is based on some practical experience done in India. So whatever research they have done, so we should use that experience, and these are the guidelines. Suppose it is written 50, you may be needing 40 or you may be needing 60 also. So based on the site condition properties which you want to get, the main marginal materials are mineral admixture already being used, but now the new thing is all these material, maybe after few years, we are replacing OPC cement. This is the new cement which we are making. We are putting sodium hydroxide, caustic soda in the fly ash, slag or silica fume. You will get a cement equal to OPC content. The work is under process at NCB, CRRI also. Maybe few years we can get that polymer cement also. And polymer concrete is already there in the market. You can make M40 grade concrete without OPC cement, without PPC cement, only using this with some alkalis. This already work is in process. And already one cement is already there. In coastal area, you have to use composite cement. 1 part cement, 1 part fly ash, 1 part slag. Any cement bag whose marking is black, it is a pure OPC cement. Any cement bag whose marking is red, fly ash cement. Any marking, blue marking, slag cement. And for bridges, already it is allowed. So section 1000 is material for bridges, bridge structure. It also allows use fly ash, use slag, use silica fume. Percentage also given as per IS code. The most important part today, which we want along with the marginal material, if you like, recently I had one project of the JP Northeast, aggregate is very poor quality. How to make it use? So I recommended them, they should use 10% silica fume, and they are getting same strength, very easy way. So like if you see the green particle, it is 20 micron cement particle. The dot is a silica fume. This research is said 10 years before. Today we are using nano silica in 3D printing. Means if you take that dot, 1,000 smaller size is that in nano silica, which is currently being used at many sites. That is 1,000 rupees or 1,200 rupees kg. Silica fume is a 30 rupees kg. So, and this is the structure. Samsung Tower we have already built in Bombay by Ambuja Cement. This is the mix. They have used M200 grade concrete. IIT Delhi, they have developed M500 grade concrete, equivalent to steel, sir. Bhattacharya sir, who is the HOD of the IIT Delhi, he has developed M500. The bulk density of silica fume is only 200. Nano silica is only 50 to 100 kg per cubic meter. And bulk density of cement is 1440. And you can see these are the IS codes are already available. IRC and IS codes are available. We can use that. Regarding FDR, the most important part, if you are using FDR, full depth recycling, there are 4 methods. First, you can use foam bitumen, you can use emulsion, you can use cutback, you can use cement also. All approximately 2%. If you take a granular material, add 2% binder, it will become CTSB, cement-treated subbase. Granular material plus 4% cement, CTB, cement-treated base, UCS 4 to 5 mega. If you put 6%, it becomes dry lean concrete DLC. If you put 15%, it will become PQC. So same method, depending upon the gradation and quality of the aggregate, we can make. And foam bitumen is just like we have a shaving cream. If you are having a shave, 3 mm thick soap, it should extend 10 times more. So what is the expansion ratio should be 10 times. And when 10 mm thick shaving cream reduces to 5, it should not take less than 6 seconds. This is the basic test when you are doing full depth recycling of a concrete with a foam bitumen. How foam bitumen is made? We put air, water, hot bitumen. You are getting the foam. You can say you will get a foam from here, and IRC code is already there. Now where it is given in IRC code, marginal materials are permitted. First is Pateria Saab's code, MORD specification. First 3 lines, moreover, in view of the increasing cost of the construction of a road, scarcity, Government of India has decided to mainstream the already available new technology, cold mix, waste plastic, modified bitumen, soil stabilized, subbase, and locally available marginal material. So this topic fits with this topic, sir. Because suppose if we use, earlier 3 villages were benefited, now 10 villages will be benefited with the same cost. Maybe slightly poor quality, there we don't have a high speed also. So it would be, that is why we do the design for rural road 90 days. Just to compromise for the stopping of the traffic up to 90 days. So more villagers will be benefited. That should be the objective. Now MORTA circular 30th August clearly says, use everywhere marginal material. Whosoever is preparing DPR or contract agreement, he must include all the waste and marginal material. I did research 23 years in 1987, sir, on recycled concrete. I have found recycled concrete is much better than conventional concrete. The results are before you, and it was published in Research Bulletin 1987, sir. If you see the result, conventional concrete, I did durability cycle, almost same. If you see the load deflection test at the corner, at the center, the edge of the concrete road in CRRI lab, everywhere you find deflection is less. What research I did, instead of taking water cementation 0.38, I took water cementation 0.36, that's all. Means just 20-30 kg extra cement I have put. So we have got almost same result. But most important part, sand should not be, recycled sand should not be used in the concrete. Only coarse aggregate. Because the water absorption of that is more than 10%, which is not permitted as per IS 383. That we can use as a filler or somewhere else. If we come to IRC SB 89, it clearly says use everywhere marginal material. Then how to use? IRC 89 specify which aggregate you have to use, where to use, base or subbase, what should be the strength. Everything is given in this chart also. IRC SB 89 table 1. If you come to again MORD specification, they have specified the strength also. As per MORTH, for sub-base minimum strength 1.75 megapascal. Here one point is to be clear. If you are doing UCS, it is the core strength. Core strength is 25% less than the cube. If you are casting cube, your strength should be 3 into 1.25. Please remember this point. If you are finding UCS, it is of the core. For finding UCS of the cube, it should be 1.25 times the UCS. As per IRCSP 72 also, design for rural road, for PMGSY road, use all marginal material and aggregate. So we should follow whatever the specification they have given, that strictly we have to follow. IRC 89, part 1, part 2, both it clearly says we should go for that. IRC 89, list of all the marginal material they have made. So we should try all this, but with soil stabilization. As it is, we should not use any marginal material. We have to process it, check it. If it is conforming to the specification by processing or as it is, then we can either washing or grinding. First, we started recycling in our country. We have given all collection of the MCD waste to 3 or 4 companies. Like in Delhi, we are given to ILFS. In Bombay also, all waste is collected by, in Delhi, in Punjab, it is collected by JP Associate. So they have cone crusher, they don't have a jaw crusher there, cone crusher, horizontal crusher, and they have a mobile batching plant also. They do the construction, they process the aggregate. Segregate, there are 20 teams. One team will take organic particle, second team will take steel, third team will take brick particle. Then they sell it, 200 rupees per cubic meter only. ILFS in Buradi, it is the plant. So, video, it will not work. Coming to the fly ash, there are 3 types of fly ash, sir. One is bottom ash. When you powdered coal is burnt in the chimney, the ash which we get at the bottom, it is only 20%. The ash, very fine spherical particle, it is 80%. The fly ash which is collected by ESB is used for cement replacement. Whereas the ash which is collected by at the bottom is used as a soil or sand replacement. In Maharashtra, Mr. Bongirwar sir, he has constructed too much length of the road. He replaced all sand with bottom ash and it is working still well. Third is a bond ash. Either fly ash or bottom ash or both. If they put in water, it is called pond ash. So chemically, all the 3 are same. For soil, these are the properties. Density should not be less than 1. Gradation is given. Only 2 tests are required. If you are using fly ash or bottom ash for the soil work, refer IRC SP 58. If you are, why we are using fly ash? Left side, cement replacement. Right side, sand replacement. So there are 3 uses of fly ash. One is for soil replacement. These are the specification. For sand replacement, right side. Cement replacement, left side. Advantage already listed. Chloride sulfate resistance. Sand replacement, bottom ash. Bottom ash can be used as a sand replacement. This is the structure. You can see the thickness. When we did metro in Delhi, in Rohini area, if you see the pier head, it was 2 meter height, sir. Today we are having pier head only 150 mm or 100 mm. The first bridge which made with the marginal material was a JJ flyover in Bombay. See how much space they have taken. Very thin pier, very thin section. They pre-stress the concrete and wherever bending moment is more, there only thickness is more. Where bending moment, so they are cutting pier like this, they are making pier like this. Wherever stresses are more, their thickness is more. They are saving material also. This is the mixed proportion of M200 grade concrete. And you can say in this project, I was involved here also, Bandra-Worli Sea Link. Because in coastal area, you need epoxy coating of the steel bar. Here we use silica fume, we didn't do any epoxy coating. If you put 10% silica fume, your strength becomes double. If you put nano silica, 3 times. So why not we use marginal material, add silica fumes? The picture is before you. Here we did pre-stressing next day. Conventionally, pre-stressing is done at 7 days. Here, pre-stressing next day we got M30 grade concrete because the strength was 150 megapascal. You can see the strength here. How much? 150 megapascal was the strength, sir. So what is ultra high performance we used in CRRI also, sir. Below the director office, 35 mm thick concrete road only. You can see today also, sir. Constructed in 2003, working today. So what is high performance? What is ultra high? That I am going to explain you. If you make a conventional concrete, it is not high performance. High performance is longer life. If you put 10% silica fume alone or 5%, the name of this concrete becomes a high performance concrete. Its permeability is almost zero. If you add fiber in it, because if you put only silica fume, if it is there are chances of brittleness. So by putting fiber in it, either steel fiber or polymeric fiber, ductility increases, post-failure ductility. It will not break. It will crack, but not break. So this is the silica fume. Slag also we are using too much. In this project, JJ flyover, we have used slag also. Any siliceous material plus cement plus fiber is called ultra high performance concrete. It is permitted by the Ministry of Transport also. There is a circular. All contractors shall use 150 megapascal concrete. Tensile strength, you can say it is given 30 megapascal. Conventional fragile strength is hardly 5 megapascal. Concrete road 4.5. 30 megapascal fragile strength is permitted as per MORTS specification. In Pune, we constructed one bridge, no reinforcement, only steel fiber and silica fume. Double-decker bridge. So this is it is also waste material, silica fume. It is a byproduct of ferrosilicon industries. We take quartz, we take wood, calcine at 2000 degrees centigrade, we can get microsilica. Bulk, now there are codes also. Now we have codes on all the mostly marginal material. You can see microfine OPC cement, like in place of grouting, you can use this for repair also. Ground granulated slag, ultra fine ground granulated slag, artificial aggregate made with fly ash only. So there is a IS code. Now in many private company, they are making aggregate from fly ash, and there is a IS code also. All hydropower projects in our country, they have used silica fume and fly ash. Because of the bombardment of the rock particle, there is zero abrasion. By adding silica fume, its compressive strength is increased, its abrasion resistance is increased. In Kota, there was one bridge fell down due to honeycombing. If you would have used silica fume or a fly ash, the voids you will not get. It will be void free also, sir.
Satyendraji, kindly conclude.
Just 1 minute. So this we have shown you. This is the double-decker bridge. This is the steel fiber they have used. This is the work in Pune, sir. Just 2 minutes, sir. This is the fiber. This is the CRRI picture. I am showing you 35 mm thick. Here, road also, that fiber is there. Post-failure, you can see the beam has broken, but it is not dividing into two pieces. So we can use for cell capacity concrete, using brick. Lastly, I am just going 2-3 slides fast. Self-fill pavement, white topping, Bangalore-Mysore Expressway, full silica fume and fiber we have used. Ultra high performance. Till today, no cracks, sir. This is the 2 slides now. Local material. We are using wood pile for ground improvement technique. Wood crash barrier already has spoken. If suppose you are having a very like black cotton soil area, put geocell, put over it, use bamboo pile or bamboo mats instead of geotextile pile. In Nagpur, full precast pavement work is going on. Full precast pavement in all Nagpur area using fly ash 20-30%. Thank you very much. This is the last slide, sir, for recycling. Thank you.
Thank you very much, Satyen Kumar ji. Satyen Kumar ji की एज अराउंड 75 ईयर्स है और वो पूरे टाइम मूविंग रहते हैं और मटेरियल टेस्टिंग और इनोवेटिव मटेरियल में काफ़ी एक्सपर्ट हैं और आप लोगों को बताना चाहूँगा कि ये काफ़ी टाइम आपके मध्य प्रदेश में ही जबलपुर, सतना, कटनी में रहते हैं और NHAI की तरफ से इनकी फॉरेंसिक स्टडी और मटेरियल टेस्टिंग में कंटिन्यूसली इन्वॉल्व हैं NHAI की तरफ से. थैंक यू सत्येंद्र कुमार जी. नाउ आई इनवाइट डॉक्टर सैमसन मैथ्यू टू स्टार्ट प्रेजेंटेशन.
Mobility and safety, these two things are very important. And as all of you know, urbanization, the vehicle ownership is in the increasing trend. Then because of many the efforts, the road network is increasing, almost 40 kilometers per day. Nevertheless, we are adding. But the issue is the heterogeneous traffic conditions. And there again, the traffic congestion is increasing and the parking issues are there. The public transportation system of the facilities is a big challenge. Then the NMD uses the difficulties, environmental impact and energy consumption, which you have been discussing in the afternoon. And finally, the road safety challenges. I will be concentrating more on road safety challenges. You'll be knowing this statistics. Almost 4.61 lakhs road crashes are happening every year in India, in which this is 2022 statistics. 1.68 lives, of course, we missed, and almost 3 times, 4.43 persons are injured. So it is alarming, and beyond that one, the young age group, especially less than 30 years, the share is more. And if you take up to 60 years, the share is almost 83.4%. It's a big number. So with the new materials or the technology, how we can reduce the crashes, lowering the environmental impact, smarter roads, and more durable and more responsive and sustainability and efficiency. I will just quickly skip these things because these are all the technologies which are coming up, maybe photoluminescent material in road markings. But otherwise, we have ARC codes and the materials are available in India. But only thing is whether we are effectively using that one according to the code. And this during the night time or in the rainy season, these materials are also available. I have seen that one in the last ARC session at Ahmedabad. We have seen that one. A material was available, and this is already in the Indian market. And because of that one, you can see that one even in the night, even the rainy season itself, now the lines are reflected. So you have a radium bead materials also available. And today morning, the minister was mentioning about the bamboo crash barriers, which is also implemented in India. So these are all the materials, and we have those things in place. Now, the technology in road safety, I wanted to concentrate more on maybe the safe vehicles, safe road use, and post-crash response. These 3 points I would like to mention here. From the reports, you can see that one. The car technology is gradually, of course, the safety aspects are increasing or developing. ABS is already there for two-wheelers and cars, even to minibuses. Then frontal head-on, or even the side lateral offset collisions. You have good the technology is available. Protection of pedestrians, vulnerable road users are also available. Then seat belts and speeding alert, airbag, these things are already available with all our new the cars. But the question is whether we are using it or not. That is the question. Then electronic stability control and automatic braking systems are available. Seat belt for driver, side door in three-wheelers. These things are all available. Of course, there is one comment that the Global New Car Assessment Program, because that video is also available, but I'm not going to play that one. It is, there is a comment that India's target to introduce protection of pedestrian feature in new models is a remarkable achievement. See, the pedestrians, according to our statistics, around 22% is the pedestrians are involved in the casualties. So the new technologies for improving road safety, probably these things are already available, but maybe we can use these things: advanced driver assistance systems, advanced vehicle control and safety system, autonomous vehicle, connected vehicles, advanced traveler information system, intelligent speed adaptation, pedestrian detection and warning system. I'll just quickly go through these things. This is ADAS. It is very common now. A lot of technology providers are available in the market now that it will detect objects, hazardous road conditions, classifies objects and known stops, slopes down vehicle, etc. All those things are already available. And these are the functions. Then these are the sensors and the ADAS controller that are available. It's already advanced driver assistance systems are already in place, and probably we can use that. Then advanced vehicle control and safety system, AVCSS, are also available, in which you have the components like the proof system, control system, the automatic vehicle monitoring, etc. are there. And you have the advanced vehicle control and safety system, in which the electronic brake force distribution, how it will be functioning, and how maybe the first figure shows that one. When it is not there, what is the distance required, and when it is CBD is there, how it will be functioning with multiple passengers and car or cargo, or the driver alone, how the things are functioning, it is given there. Then we have this electronic stability control, in which with and without electronic stability control, how the car will be taking the route, it's also given with the description. Then autonomous vehicle. We have the autonomous vehicle technology is also available. The video is also, forget about it. Then these are all the different components of automobile, autonomous vehicle, in which you need a GPS, then LiDAR concept, cameras, then sensors, etc. and all. And this is the technology is also available. We have connected vehicles. Technology is already available. Vehicle to everything, not to vehicle to like a vehicle or vehicle to infrastructure and all. Even vehicle to everything technology is also available now. Probably this figure shows how a vehicle can be communicated to different the other whether to vehicle network or maybe to the pedestrians or even to the other vehicles, etc. Okay. So this is the way how these things are available. And advanced traveler information system is especially in the developed countries and all, they are using that one, predicting the time requirement to reach the destination and other things and all, and probable the difficulties on the route. All those things are also available. And this is also available now, like intelligent speed adaptation. ESA is also, the technology is available. Suppose that the driver is missing certain informations, and the vehicle will identify that one, and accordingly it will act. And this is very, very important, especially in the case of urban intersections and all, where the pedestrian detection and warning system, it's also, the vehicles are also available with that. And we have one Kerala Road Safety Authority. It is in place from 2007 onwards. It is coming with the act. It is created with an act there in Kerala, and it is functioning there. We have a lot of activities under this umbrella, Kerala Road Safety Authority Act 2007, and a lot of agencies are also involved in that under that KRSA, and the funding is coming from the road tax, and a portion of the road tax, 50%, is exclusively reserved in the Kerala Road Safety Authority, and that fund will be used for the safety-related activities and all. We have done one project
in association with Keltron, that is an electronic, the government undertaking agency, in which the emergency management system, how that emergency vehicle, when it is approaching an intersection, with a signal intersection, how the signal phase can be changed when that signal is, the vehicle is approaching the signal. Then that red signal become green, and what is that amount of time which we can save. Okay. In fact, I have a video also for that one, in which we found that one. Now we found that one, on an average 10-second is time we are saving. See, the red signal is there, and the ambulance is also waiting for the green signal, but it is missing. Okay. And when this the emergency ambulance detection, this is connected, you can see that it is split into two. You can see that it's a busy intersection. The actual the time taken is 32 seconds, but with the EVPS, you can see that one. When the vehicle is approaching the signal, that signal become green. You can see that one, and there is a saving of time. There is a saving of probably that 10 seconds time may be important, and if it is in a busy corridor. And when you have that listener savings, if it is cumulated, listener probably you will have a maybe that probably we can save the time. We have another World Bank supported project. Probably this marking on this road is slightly different from that of our the marking on the road. Okay, this was you can see that one. This is a model corridor which we have constructed for about 80 kilometer. 80 kilometer. I will show you how that design it is. We have implemented that one. See, even certain the visual the messages are also given on the road. So the road user will be in a position to check what is the listener he should do, like a slow stop, then in the case of the pedestrian crossing, or maybe in the case of school and all, how listener should be he should be careful. That again we have this is there. Especially I will show you how this same concept is. Now, this is the 80 kilometer state highway number 1, the Safe Corridor Demonstration Project, supported by the World Bank. And average paved width is only 12 meter, and the right of way is around 15 meter, and a 2-lane two-way. And like any other road, we have all these problems there again in the road. And the task carried out, we have analyzed what was the number of accidents earlier in 2015 to 17, and it was implemented after the construction has taken place 2017 to 20, and we have done the effect of that one is also evaluated after that implementation. And this is the type of crashes, and on an average you can see that one per year average crash was for 80 kilometers, it was 507, and the victims were 728. And there again,
vulnerable road users who are more in that number stretches, and that is something to be considered. So this is that marking which of course, in Kerala we have a difficulty that the availability of or the land acquisition is a big challenge. So we cannot correct some of the curves, or we cannot widen that one. So whenever this is a state highway and the radius of curve, when it is less than 160, yellow ladder is given, and then double yellow continuous line, double white continuous line, like that. We have different the markings are given. Some of the examples are given here. You can see that, and it is a very tight curve in which the central line is provided with a yellow, and then probably you can see that one, it is a ladder type division is given. This is another curve, and where you can see that one, the no parking, and even the shoulder is also, it is different marking is given there. And this is before marking and before improvement and after improvement. Then these are the different road markings and the ladder, other things are given. And we have given the pedestrian facilities are also designed separately. And the school zone treatment, where you have that 30 kilometers per hour, that during the school timing, and you have a different marking for that one. Intersection markings. Then this is again another major intersection. This is the start of that stretch, and this is that one national highway is crossing this state highway. This is the treatment which we are given. This is the end point of that one. And we have done what is that effect of this one? Of course, naturally, these are all new markings. We have to educate the lesson of the users. And that again, we did that one. And the effect of that one, we found that one, people were reacted positively to these markings and all. You can see that one compared to many other states. I wanted to tell you that the helmet, the seat belt lesson, the compliance is more in Kerala, even before the A cameras. Again, I'm going to explain that one. And we have seen that one, the seat belt or the helmet usage is even both the passengers in the front seat, they were using that one. That is something which I wanted to mention here. And I'm very sorry to mention that the driver who he was taking me from airport to hotel yesterday. He was not using the seat belt, and there will the beep sound was also coming, but he was not bothered to that. And that is the situation. Okay. And the pedestrian compliance to zebra crossing, that again it was very positive. People were they were forced to they are directed to cross only through the pedestrian crossing. But this is one thing, when the road is improved and you have a better geometry and all, we found that when the speed, especially the higher speed, the more drivers tend to use higher speeds. That is one difficulty which we noticed. Okay, so the non-compliance about that. Okay, this I already shown. Of course, we have a lot of good points there. Even the independent evaluation by external agencies also, they also found that one. This is a very effective lesson of the corridor. But only thing is, this should be extended to this, of course, the new IRC code, of course, it covers all these details. And this should be extended to other major roads also. This is another a new technology which I wanted. 1 minute, sir. I'll finish it. Okay. I wanted to mention that we have introduced around 726 AA cameras. We placed that one in our road network. Okay. So you can see that one AA camera, and it is in a position to identify the vehicle, the number of passengers, and in the case of the two-wheeler, if if more than 2 passengers are there, the camera will identify. If the seat belt is not there to the driver and the front seat passenger, if it is there, it will identify, and automatically the challan will be created. That is there. So this is that we have implemented 726 cameras, in which 675 is AI-enabled, 25 cameras for respecting parking violations, 8 for the speeding, and 18 for the red light violations. All these mistakes it is possible to identify by that AI. And according to the technology provider, they said it is possible to include more in that one. And this is that which I wanted to mention, that it reduced the
Please conclude.
It reduced the number of fatalities and crashes. See, according to the as per the CRRA calculation, a huge sum we are saving by enforcing this one. And we have found that one, we spent almost 230 crores or so, but the fine alone in 1 year, it is coming around 437 crores. Okay, so the investment, it is a good project for a PPP mode.
Please conclude.
Yes.
Dr. Matthew.
And I wanted to finish with this one. See, of course, you cannot read that, it is in Malayalam. And that kid is only 2 years old. And that she had a very, very bad, the incident in which the airbag, she was on the front side with the mother, and mother was keeping her. And in an accident, what happened? The airbag has come and it hit the kid, and she's no more. So when we are using that the advanced technology and all, we should be careful about these things also. This is what I want.
Okay, thank you. Thank you, Dr. Matthew. Next presentation, experience on white topping by Ultratech, Mr. Nagesh Puttaswamy. 10 minutes for your presentation. I request you to kindly finish within 10 minutes.
Good evening, and I have a lot of information here, but I will conclude within 10 minutes. I am available for individual discussions in the Ultratech stall. Any specific questions? I was told that there are a lot of questions. In fact, I came here, before that I had one question from somewhere there about white topping. So let me start with my presentation. This is how the scenario looks like when slightly educated people look at white topping as a technology. Technology 5-star, and equipment is fascinating for people to see. So those equipment 5-star. Then the material is always questionable. I do not know whether really we are not able to deliver, or we have not been able to convince people that the concrete that we are pouring there is of good quality. And my experience of working from Jammu and Kashmir to Kanyakumari, Assam to Rajasthan, I have built white-topped roads. The skill set required is nowhere near what is required for the equipment and the concrete that we have brought in. Performance, yes, the material is good, but the performance, everybody says the road is bumpy. And well, we are taking the disguise that this is a new technology. It's a new technology in India, but the white topping as a technology for concrete road or overlaying of concrete road is about 100 years old. Well, the first thing, what I generally feel, I'm not going to talk more about designs. There are experts, but my experience as a person, material technologist, sitting in the concrete road, able to do roads everywhere thanks to the government and all the agencies. I found that there are some small areas that are not covered in our documentation only, especially in urban areas. Road is, DPR is done, estimation is done, tender is floated, not enough allocation for diversion boards, not enough allocation for barricades. Now there is a huge chaos for which weeks and weeks of work is delayed. That is where we have to sit together, we have to look out for that. work is designed by civil engineers, the traffic is controlled by a traffic cop who might not be even a science student. So right from tendering, there has to be, this is a new technology in that we are getting into. Let us sit together, let us talk to each other about all the necessities. And the problem now people are facing, I always pity the government engineers who are working at site. Very rarely they will be exposed to new kind of technologies, formal training and other things. The two things there, you can see that is how they feel when there is, they know that that has to be done, but there is no provision for money allocation to do that work. That is how they feel, and in fact, I have been sitting with them several times. In fact, I would like to share something. The very first concrete white topping that I did, I was put behind bar for 7.5 hours for not allowing a policeman to allow traffic to go. So these are the stages that we will have to look out for. Everywhere a cross-table discussion has to happen, and that is what I am seeing, that I am missing it to happen. And very important is many of us as designers of the materials and the designers of payment technology implementation, we are not looking into the DPR. I have seen roads where the DPR clearly says there are 3 hospitals, 4 schools, and 1 government revenue department office, and the tender document floated says the work has to be handed over in 7 weeks. I don't know, how do I manage? So the documentation is there. If I link all the codes that are linked, I always see that people doing white topping look at only the SP 78, or a maximum few of them will look at IRC 44, but they never look at the procedures mentioned for concrete pavement in IRC 15, nor they would look at the equipment. There is a IRC code for plant and machinery for cement concrete. They don't look at it. And very rarely they look at a very important code. I have worked in 2 extreme conditions. I have made concrete at -8 degrees in Jammu Kashmir last winter. I am proud to say that we Indians have done concrete roads, concrete pavements throughout the last winter. We have not stopped working except when there was a 2-meter snowfall between the 3rd week of January and 3rd week of February of 2024. 4 weeks we had 2-meter fall snowfall. Only then we stopped working, but we continue to work. The only line of instruction to my team working there, of course I don't have my own team, I work with others. जब तक पानी बर्फ नहीं बनेगा, हम लोग concrete डालते रहेंगे. The one line instruction, everybody there, thanks to the Indian Army guys, they did the work like that. Very important is something that is always challenging is utilities. But what we do not know, I can, for all the chief engineers and superintendent engineers here, you please invite me. I can conduct a full 1-day workshop on how to construct these roads, which includes CC road to short panel roads and white topping. I can conduct, but still here I just have a lot of pictures. I can explain one picture, each stories of what we have experienced over a period of time. Simple, the way that the urban people are looking at my road is totally different. Cycle tracks, footpath, comfortable footpaths is something that people are talking about. Underground gas lines, underground water supply lines, underground sewage lines, then rainwater, stormwater drain, and unseasonal rains, once in 100 years, once in 200 years rainfall hitting each city. Name the city, they all have got the highest rainfall in 100 years, and we came to know that our drainage system is clogging. But my personal survey with my students is indicating that we do not know how to maintain it. We had enough and more area of drainage, but it was filled with sanitary napkins, diapers, water bottles, milk sachets. So where does the water go? This is what we have to look at as a system. And very important, I would say that these are the equipment that is readily available in India, the underground scanners. We pour concrete. Tomorrow morning, my people are cutting, as Professor was telling, 12 to 15 hours. I have to cut my concrete. The water supply guy comes there, says, "यहाँ तो hospital जाने वाला पानी का pipe है." I have already done my concrete. This is something that we will have to make it mandatory, and we will have to work together. In Bangalore, I faced this for a very, very long time. I have laid more than 200 kilometers, or I have been involved in laying 200 kilometers of white-topped roads. Today, everybody is served a notice to attend the meeting before a road commences. Then the codes are there. There is a huge list of codes. Probably you will have to look out for all of these things. Shoulders is another thing. This is the main reason many of the concrete roads are failing from edge towards inside. We are not treating the shoulder as it has to be treated for a concrete road. Shoulder, copy paste, जो वहाँ था यही को भी लेके आ गया, but my relative edge threshold requirement is different. But fortunately, we have a lot of equipment, lot of precast members that can be used to be a threshold between the edge of the concrete road and a stable shoulder. That can be done. Of course, we from Ultratech, we are trying to, wherever it is applicable, we are trying to use the no fines concrete or permeable concrete so that we can take away the water to a designated place. Then the shoulders are different for different places. Highways, it is different. Pavement inside a city, it is different. And habitats, it is different. Hilly areas, it is different. There are equipments, all these photographs are done in India. We are using this once in a while, but not regularly. DLC plus a layer of 1 or 2 grade lower than the PQC being a shoulder is getting popular in many places. Of course, fully stabilized soil with a layer of super.
Please conclude, Mr. Nagesh.
Yes, sir. These are things that would be looking at. Shoulders, then drains. After that, I would say everything is possible. This is something that you have to look out for. There are very good concrete mixes that are available. What you see here is what we did in Jammu Kashmir. And I would take you for one simple thing. Everything is possible today. I will take you to the last part of this. These are some things that we have to adopt. There is Sheltec boards that can make our expansion joints a very delicate, true edge joints. Cut them. You can drill holes in it. You can make slots in it. Make a clean joint for your thing. And
Please
the other
conclude.
thing, this one.
Mr. Nagesh, please
Yes,
conclude.
sir. Nothing is impossible. This is the road that we built, White Topping Road in Jammu Kashmir.
Thank you very much, Mr.
Thank
Nagesh.
you. And anything else, I am available in the
Last
Ultratech.
presentation on repair of rigid pavement by Mr. Pallavi, Mrs. Pallavi, Miss Pallavi.
Thank you. Couple of pictures there belong to the Indian Army. So I would request the organizers to please delete my presentation.
10 minutes for your presentation. I request you to kindly conclude within 10 minutes.
A very good evening to all of you. Not taking much of your time and not an expert. I'll just briefly describe about our company. Our company, Natural Semeco Private Limited. We work on geopolymer technology, which is, as Honorable Minister mentioned in the morning as well, he turn waste into wealth, and that is what we exactly do. We turn the waste into wealth, and we come out with curing-free solutions, saving your time, water, and resources. So quickly coming to the our things. So this is our journey. We started in 2008, and this is where we are standing in 2024. So this is something, these are the general challenges which as an engineer you all must have faced throughout your career. There are problems of traffic jams during your CC road constructions or repairs. There are problems with the timelines. There are problems with the water availability for curing. There are problems of road cracks, durability, and uneven and bumpy roads. So this is a product which we'll be talking about today. It is Technopatch EX, which is a curing-free. I again would mention it's an absolutely curing-free product which is used for your pothole and CC road repairs. It comes in a premix bag which is a 25 kg or a 50 kg or a jumbo bag. It has to be laid on a 50 mm thickness, and you can mobilize your traffic in as good as in 2 hours. You don't need to do curing at all. So we always face a problem like we have dense populated areas, or we have areas which are very narrow where we can't stop the traffic. This is a thing which will help you out in those zones. So, and we often also listen to this by public whenever we do a CC road repairs. अभी तो ठीक किया था, वापस खराब हो गया. क्यों खराब हो गया? क्योंकि तराई नहीं हुआ. क्यों? क्योंकि उसको strength नहीं मिला. So this is a product which does not need curing at all. It is a few other features. It is quick setting. It gains early strength as good as a strength of around M35 in your first 4 hours and around M40 in first 24 hours. It is absolutely curing free. The rapid return to service is in 2 hours. It is non-shrink, and of course, as it is curing free, it is eco-friendly as well. So the application process is quite simple. It is a basic surface preparation, cleaning of the surface, pouring the material, and you're good to go in 2 hours. So these are the few VIP visits done at our sites. So we are working in multiple states: Rajasthan, MP, Maharashtra, Chennai, and we'll soon be opening our arms to Gujarat and Himachal as well. So this is a recent site we completed with Indore Municipal Corporation. As you know, Indore has a lot of CC roads, and they had been facing a lot of problems with their repair solutions. So this is a recent site we completed for Indore Municipal Corporation. So these are the few site pictures. I would like to mention this particular product is applicable on your CC and bitumen roads both. Generally, we have an issue, a solution which is applicable for bitumen is not applicable for CC, but a CC solution is not applicable for bitumen. But in this case, it is applicable for both. Now coming to the second product. So when we talk about the construction, then there are problems of curing. 28 दिन तक पानी देना, पहले ठेकेदार को 2 लेबर लगाना, उस ठेकेदार को मॉनिटर करने के लिए एक अपना ऑफिसर लगाना, उतना पानी अरेंज करना. There are places where we don't have water. I belong to Rajasthan, so Rajasthan being a dry state, we often face problems कि वहाँ पर पानी नहीं मिल पाता है. इंसानों को ढंग से पीने के लिए पानी नहीं मिलता है, और हम कंस्ट्रक्शन के लिए पानी चाहते हैं. So coming with our solution, easy additive. So these are the general curing things what we do. We do these gunny bag things, we make square, we put water in that, but ultimately we often fail in curing challenges. The major problem faced by every engineer is that we can't cure our projects properly. So this had been a traditional water curing method. Then curing compound came. Again, curing compound method, when it came with a lot of challenges. It was not a 100% solution to our curing needs. Then came up the thing which is zero curing or a curing-free concrete. Easy additive is a solution to that. Easy additive is a product which makes your concrete absolutely curing-free. Again mentioning it, absolutely curing-free. be it your building construction, bridge construction, retaining walls, roads, everything, it is making your concrete absolutely curing free. For these, all the both the products, we have tested reports from IIT. So you can be confident about both the technologies. So these are patented. It is a very easy to use product. It generally goes 2% by weight of cement, which is the highest dosage you need to put for the highest grade. It varies from 1 to 2% depending on the grade you are doing the concreting for. So it is making your concrete absolutely curing free. In first 48 hours, you're getting a strength up to 50%. In 7 days, you're getting it more than 95%. So of course, it is reducing your time, it is reducing your water needs, and it is of course reducing your cost as well. So it makes your concrete curing free. It helps you attaining early strength, low cost of maintenance, increased durability, reduced shrinkage in concrete, and helpful in reducing daily cost management. It comes in a powder form, directly to be mixed with your concrete, whether it's an RMC, bulk, anything. You can just directly mix it there at a dosage of 2% by weight of cement. So this is what we propose to the government, making constructions curing free in terms of saving water, saving cost, saving resources, and making your repairs curing free in order to again save cost, save time, and save the problems faced by general public. So that is it. Any questions? Most welcome. Thank you, sir. These are few of our clients. So we had been working with multiple government organizations as well as BRO and MES as well.
Thank you, Pallavi. Thank you very much. Now floor is open for the discussion. Any question from the delegates? I think now it is already 7 o'clock, so no question. I request co-chairperson to sum up the session.
थैंक यू सर. सेकंड सेशन के हमारे सभी पांचों प्रेजेंटर ने बहुत अच्छा प्रेजेंटेशन किया है. जो पहला हमारा न्यू मटेरियल एंड टेक्नोलॉजी फॉर कंस्ट्रक्शन ऑफ मेंटेनेंस और रिजिड पेमेंट में प्रोफेसर एम ए रेड्डी साहब ने बताया कि जो हमारे 60 पैनल में कंक्रीट करते हैं उसमें हमें कंक्रीट की थिकनेस कम हो जाती है और हमें जो स्टील है वो उसकी बचत होती है. इस ओवरऑल हमारी कास्ट सेविंग होती है जो हमारे देश और प्रदेश के लिए आज आवश्यक है. इससे हमारे प्रदेश और देश के लिए काफ़ी महत्वपूर्ण है, जहां लगभग 25 से 30% कास्ट सेविंग हो रही है. तो आज इस प्रेजेंटेशन से हमें काफ़ी प्रदेश को बेनिफिट होगा. दूसरा जो प्रेजेंटेशन था हमारा यूज ऑफ मार्जिनल मटेरियल इन रोड एंड ब्रिजेज, श्री सत्येंद्र कुमार जी, इनके द्वारा जो लोकल मटेरियल की यूज के लिए बताया, जिससे हमें दोनों प्रकार हमारे जो प्रोजेक्ट हैं स्पीडली पूरे होंगे, कास्ट सेविंग होगा और टाइम की बचत होगी. तो इससे भी हमारे प्रदेश को काफ़ी बचत होगी और हम लगभग जो है 20 से 25% जो है वर्क ज़्यादा कर सकते हैं. और इन्होंने बहुत डिटेल बताया है, इसका अच्छा बेनिफिट होगा. तीसरे प्रेजेंटेशन है न्यू मटेरियल एंड टेक्नोलॉजी फॉर इम्प्रूविंग रोड सेफ्टी बाय डॉक्टर सैमसन मैथ्यू. आज जैसा हमारे उद्घाटन सत्र में हमारे मुख्य अतिथि महोदय ने चिंता व्यक्त की, जो मैकेनिकल इंजीनियरिंग है उसमें हम काफ़ी हद तक सफलता प्राप्त कर ली हैं, लेकिन सिविल इंजीनियरिंग में हमें काफ़ी कुछ करना है. जो हमारा सिनेरियो है एक्सीडेंट का, मौतें का, और 1.78 लाख पर ईयर है, इसको हमें मिनिमाइज करना है. उसके लिए हमें रोड सेफ्टी में काफ़ी काम करना है और नई तकनीकी के माध्यम से हम उसको कम कर सकते हैं. उन्होंने चिंता जाहिर की कि 18 से 40 वर्ष के युवा हमारे इंजीनियर, डॉक्टर, साइंटिस्ट जो है अपनी जान गंवा बैठते हैं रोड एक्सीडेंट में, जबकि किसी भी बीमारियों से इतना नहीं हुआ है, इवन कोरोना से भी नहीं हुआ है. तो इसको हमारे लिए चिंता का विषय है. वो हम चिंता इस प्रेजेंटेशन से काफ़ी हद तक सीख लेंगे और रोड सेफ्टी नई टेक्नोलॉजी का उपयोग करके काफ़ी हम एक्सीडेंट को कम कर सकते हैं. चौथा जो प्रेजेंटेशन था हमारे श्री नागेश पुट्टा स्वामी जी द्वारा जो वाइट टॉपिंग के बारे में उनका अनुभव था, उन्होंने बताया कि हम कितने कम टेम्परेचर में भी हम कंक्रीट का काम किया है कि जब तक बर्फ़ जो है पिघलना, जब पानी नहीं बने, जब तक हम काम करते रहे हैं। उनका अनुभव काफ़ी मदद मिलेगी वाइट टॉपिंग, क्योंकि अभी हमारे प्रदेश में वाइट टॉपिंग के नए प्रोजेक्ट लिए हैं, तो उसमें हम लोगों को काफ़ी मदद मिलेगी और निश्चित है हमारे प्रदेश को जो है उसका लाभ मिलेगा। लास्ट प्रेजेंटेशन है मिस पल्लवी के द्वारा जो रिजिड पेमेंट का। आज जितने रिजिड पेमेंट है प्रदेश और देश में, सबसे ज़्यादा जो है पार्ट होल से क्रैश की समस्या आती है। और उन्होंने जैसे बताया अपने प्रेजेंटेशन में कि हम रिजिड पेमेंट में जो कंक्रीट से पैच रिपेयर करते हैं, क्यूरिंग की समस्या रहती है। उन्होंने बड़े ही कम उसमें अच्छा प्रेजेंटेशन बताया है कि जो हम 2 प्रकार की मटेरियल यूज कर लेते हैं, क्यूरिंग फ्री मोटर्स एंड इजी एडिप मिला के। दोनों में हम चाहे बीटी फ्लैजी पेमेंट हो चाहे रिजिड पेमेंट है, दोनों में उपयोग कर सकते हैं। इसके पहले अभी जो मध्य प्रदेश में जो लोकपथ ऐप का उपयोग किया गया है, उस समय हमारे प्रमुख अभियंता महोदय ने बताया कि हम चूँकि बरसात हो रही है तो हम बीटी पैच रिपेयर नहीं कर सकते, तो हम कंक्रीट के द्वारा कर सकते हैं। ये हमारे बरसात के समय विशेषकर फ्लैजिड पेमेंट के लिए बहुत महत्वपूर्ण है। बाकी ओपन ऑल सीजन में रिजिड पेमेंट के लिए काफ़ी उपयोगी है। आप देख जितने भी हाईवेज हैं सभी जगह समस्याएं हैं, पार्ट होल्स और क्रैक्स, चाहे लॉन्ग क्रैक्स हो चाहे क्रॉस सेक्शन क्रैक्स हो, इनको इन दोनों तकनीकों के माध्यम से हम अच्छा इसका उपयोग कर सकते हैं। धन्यवाद।
कंक्लूड करने से पहले एक महत्वपूर्ण सूचना आपको देना चाहूँगा। राइट आफ्टर दिस सेशन, जिस ऑडिटोरियम में सुबह इनॉग्रल फंक्शन हुआ था हंस ध्वनि सभागार में, उसमें कल्चरल नाइट का आयोजन किया गया है। इस कल्चरल नाइट में देश की प्रख्यात नृत्यांगना सुश्री रागिनी मक्खर जो इंदौर से पधारेंगी, वो अपनी नृत्य नाटिका बाबा महाकाल पर आधारित एक शानदार प्रस्तुति देंगी। ठीक उसके पश्चात इंडियन आइडल पवनदीप और सुश्री आकृति मेहरा मुंबई से पधारे हैं। इन लोगों की शानदार रंगारंग प्रस्तुति होगी। आप सभी लोग उस हंस ध्वनि सभागार में उपस्थित होकर कार्यक्रम का आनंद ले सकते हैं। अब मैं आज के चेयर श्रीमान के पीपरी साहब से रिक्वेस्ट करूंगा कि वे प्रोफेसर M.A. रेड्डी साहब और श्री नागेश पुट्टास्वामी जी और मिस पल्लवी बरजात्या जी को मोमेंटो प्रदान करें। श्रीमान पीपरी साहब। सेशन के को चेयर श्रीमान S.A. सूर्यवंशी साहब से अनुरोध है, कृपया M.A. रेड्डी साहब और श्री सत्येंद्र कुमार जी और डॉक्टर सैमसन मैथ्यू को मोमेंटो प्रदान करने का कष्ट करें। Now I will request Vice President IRC and Secretary PWD Maharashtra श्री S.S. सालुंखे साहब कृपया मंच पे आएं और चेयर को मोमेंटो प्रदान करने का कष्ट करें। श्रीमान S.S. सालुंखे। This is how we come to the conclusion of technical session today. Thank you so much. बहुत बहुत धन्यवाद. Thank you so much.